Hello there, and welcome to Science for Sleep, where curiosity gets cozy and science takes the scenic route to slumber. Tonight, we're turning our attention upward to something you've likely seen countless times, perhaps without giving it much thought at all. A quiet presence in the sky, familiar, steady, almost comforting in its predictability. The moon. Now, it's easy to think of the moon as something distant and harmless, just hanging there, doing its own thing, minding its business while we go about ours. It rises, it sets, it changes shape night after night like a slow, patient performance. Sometimes it's a thin crescent, sometimes a glowing full disk that lights up rooftops and treetops, and most nights it simply feels reliable. But let's take that familiar idea and gently nudge it just a little. What if that quiet companion wasn't quite as stable as it seems? What if, instead of drifting peacefully in its orbit, the moon began to move differently? Subtly at first, almost unnoticeably, and then more clearly, more deliberately, closer. Not in a dramatic, sudden way. Nothing that would send alarms ringing overnight, but slowly, gradually, like something shifting just out of the corner of your eye. What would that feel like? What would we notice first? And perhaps more curiously, what would happen if the moon, that distant and steady presence, began a long, inevitable journey toward Earth? Before we wander too far into that thought, let me ask you something simple. Where are you listening from tonight? Are you somewhere quiet, maybe with a window nearby? Is the sky clear where you are or covered in clouds? And if you happen to know, what time is it right now in your little corner of the world? It's a slightly fitting question, isn't it? Because while we're all sharing the same story, we're each doing so at a different moment, under a different sky, with the moon in a slightly different position above us. Some of you might be looking at it right now, others might be hours away from its rise, and some might have already watched it set. If you find this kind of slow, curious exploration relaxing, or just a gentle way to unwind at the end of your day, I'd really appreciate it if you gave the video a like and maybe subscribed. It helps this calm little corner reach others who might be looking for the same kind of quiet curiosity. Now, I'll do my best not to make this so intriguing that it keeps you wide awake, but if it does, well, at least you'll have taken a thoughtful journey through one of the more unusual what-if scenarios our universe can offer. So, settle in. Let your thoughts slow down a little, and let's begin with something simple. Because before we imagine the moon falling toward Earth, we should take a moment to appreciate just how steady it really is. Right now, as you sit or lie there, the moon is orbiting Earth at an average distance of about 384,000 kilometers. That's far enough that it feels untouchable, almost like part of the background of the universe rather than something physically connected to us. But it is connected. In fact, the moon and Earth are locked in a kind of gravitational dance. The moon pulls on Earth, and Earth pulls on the moon, each influencing the other in ways that are subtle, but constant. This balance is what keeps the moon in orbit, circling us in a predictable path that takes about 27 days to complete. It's not just floating there by accident. It's moving sideways fast enough that, as it falls toward Earth under gravity, it keeps missing, over and over again, a continuous fall that never quite reaches the ground. That's what an orbit really is. Not a perfect circle drawn in the sky, but a kind of perpetual near miss. And this balance has been stable for billions of years. In fact, the moon is slowly drifting away from us, at a rate of about 3.8 centimeters per year. Not much, about the speed your fingernails grow, but over millions of years, it adds up. The moon is very gradually moving farther away. So if anything, the real story of the moon is one of slow separation, not sudden approach, which makes our question all the more unusual, because for the moon to crash into Earth, something would have to change that balance. Something would have to disturb that long-standing gravitational dance. And here's where things start to get interesting. Imagine for a moment that something nudges the moon out of its stable orbit. Not a dramatic shove, but just enough to alter its path. Maybe a passing asteroid, or a distant gravitational interaction, or some subtle shift over time that accumulates into something more noticeable. At first, nothing would seem different. The moon would still rise and set. It would still change phases. It would still look to most of us exactly as it always has. But astronomers, the people who watch the sky with careful precision, would begin to notice something unusual. The timing would be slightly off. The position of the moon against the background stars wouldn't match predictions perfectly. Tiny discrepancies at first, the kind that could be explained away as measurement error. But then, over days or weeks, those discrepancies would grow, and eventually it would become clear. The moon's orbit is changing. Now even then there would be no immediate danger. The distances involved are so vast and the timescale so long that any approach would take time, plenty of time, but the idea itself would begin to settle in. The moon is getting closer, and that realization would likely spread slowly, much like the change itself. Scientists would publish data, news outlets would pick up the story, conversations would start to shift. At first, it might feel abstract, something interesting but distant, like hearing about a faraway storm that hasn't reached you yet. But night after night, the sky would begin to offer its own confirmation. Because the moon wouldn't look exactly the same anymore. It would appear slightly larger. Not dramatically, not enough to startle anyone right away, but just enough that, if you were paying attention, you might find yourself pausing for a moment thinking, that seems a bit bigger than usual, and you'd be right. As the moon moves closer, its apparent size in the sky increases. That's a simple consequence of perspective. The closer something is, the larger it appears. Normally, the moon's size can vary slightly due to its elliptical orbit. Sometimes it's a bit closer, sometimes a bit farther. This gives us what's called a supermoon, when it appears slightly larger and brighter than usual. But what we're imagining here goes beyond that. This wouldn't be a small variation. It would be a steady, noticeable growth. Night after night, the moon would take up just a little more space in the sky. At first, it might even feel beautiful. There's something undeniably striking about a large moon. It draws attention. It changes the feel of the night. Shadows become sharper. The landscape takes on a kind of silver glow. People might step outside more often, just to look at it. Photographers would capture it. Conversations would circle back to it again and again. Have you noticed how big it looks lately? And slowly, almost imperceptibly, that sense of curiosity would begin to mix with something else. Because as the moon gets closer, it doesn't just look different. It starts to affect Earth more strongly. Gravity, after all, depends on distance. The closer two objects are, the stronger their gravitational pull on each other. And the moon's pull on Earth is already responsible for something we experience every single day, whether we notice it or not. The tides. Right now, the moon gently pulls on Earth's oceans, creating bulges of water that we experience as high and low tides. It's a steady, predictable rhythm that coastal regions have adapted to over countless generations. But if the moon were to move closer, that pull would increase, and the tides would begin to change. At first, the difference might be subtle. Slightly higher high tides, slightly lower low tides, the kind of variation that might be noticed by those who pay close attention, but not by everyone. But over time, as the moon continues its approach, those changes would become more pronounced. High tides would rise higher, low tides would drop lower, the oceans would begin to move with greater intensity, responding to the growing gravitational influence above. And once again, it wouldn't happen all at once. It would be a gradual shift, something that unfolds over days, weeks, perhaps even longer, depending on how quickly the moon's orbit changes, which means that for a while, life would continue. People would go to work, conversations would happen, daily routines would carry on, but in the background, something fundamental would be changing. The sky would look different, the oceans would behave differently, and somewhere, quietly, the realization would continue to settle in. The moon is not where it used to be. It's closer, and it's still coming. Drifting a little further into this quiet thought, it helps to return to something simple and familiar before anything unusual begins to unfold. Because long before we imagine the moon doing anything dramatic, it's worth noticing how deeply ordinary it feels. Step outside on a clear night, and there it is. Not demanding attention, not changing suddenly, just present. A pale shape in the sky that seems to belong there in the same way rooftops belong to a city, or trees belong to a forest. It doesn't rush, it doesn't flicker, it just keeps showing up. And that quiet reliability is part of what makes it so easy to overlook. You might have seen it last night without really thinking about it. Maybe it was hanging low near the horizon, a little golden and distorted. Maybe it was higher up, smaller, sharper, more distant. Or maybe it was hidden entirely, tucked away in its new moon phase, letting the sky go dark for a while. Whatever the case, it likely didn't interrupt your evening. It didn't ask for your attention. It simply existed in the background, like a familiar piece of music you've heard so many times you no longer notice when it begins. But if you pause for just a moment and actually look at it, something interesting happens. The moon starts to feel less like background, and more like a companion, not in any mystical or poetic sense, just in a very simple, observational way. It's always there, moving along its path, keeping pace with us as Earth turns beneath it. Different people in different places at different times, all seeing the same object, just from slightly different angles. Right now, wherever you are, the moon is somewhere above Earth, maybe above your horizon, maybe below it, but always present in the same shared sky. And that alone is a little grounding, because while so many things change from day to day, the moon gives us something steady to return to, a reference point, a rhythm. It rises, it sets, it cycles through its phases. Crescent, half, full, and back again. Not in a hurry, not trying to impress, just following a pattern that has been repeating for billions of years. And over time, we've quietly built parts of our lives around that pattern. Long before clocks and calendars, people used the moon to keep track of time. Its phases offered a natural way to divide the month. Its light helped guide travellers at night. Its presence shaped stories, traditions, and small rituals that still linger today. Even now, without thinking about it too much, we still respond to it. A full moon often feels different, even if we don't consciously acknowledge why. Nights seem brighter. Shadows stretch a little more clearly. The world takes on a slightly altered tone, just enough to notice if you're paying attention. And yet, for all its familiarity, the moon is still quite strange. It's not small, for one thing. From where we stand, it looks modest, something you could almost cover with your thumb if you held your hand out at arm's length. But in reality, the moon is about 3,474 kilometers across. That's roughly a quarter of Earth's diameter. It's closer to us than any other celestial body, which is why it appears so large in our sky. Larger than any planet, larger than any star, simply because it's nearby. And nearby, in space terms, is still quite far. If you could somehow line up 30 Earths side by side, that's about the distance between us and the moon. Not something you could casually cross, not something that feels immediate, and yet, visually, it feels close enough to matter. That balance between distance and familiarity is part of what makes the moon such a constant presence in our lives. It's far enough to feel separate, but close enough to feel connected. You can see its surface with your own eyes, the darker patches, the lighter highlands, the patterns that have been given names over centuries. Seas, or Maria, though they're not seas at all. Just vast plains of ancient lava, frozen in place. If you've ever looked closely, you might have noticed those markings forming shapes. Some people see a face, others see animals, figures, patterns that seem to shift depending on how you look at them. It's a small, human habit, finding meaning in shapes, even when we know they're just random formations, and the moon invites that kind of attention. It doesn't overwhelm you with detail. It gives you just enough to notice, just enough to recognize, and leaves the rest to your imagination. But beyond what we can see, the moon is also quietly interacting with Earth in ways that are easy to forget. Every second, it's pulling on our planet with gravity. Not enough to drag us off the ground or cause anything dramatic in our daily lives, but enough to move entire oceans. Twice a day, the seas rise and fall, responding to the moon's position. Coastal areas experience this rhythm constantly. It's built into the timing of tides, into the habits of marine life, into the routines of people who live near the water. And even if you're nowhere near an ocean, that gravitational connection is still there. The moon is gently influencing Earth, and Earth is influencing the moon in return. In fact, the moon is tidally locked with us, which means it always shows the same face toward Earth. The side we see now is the same side people saw thousands of years ago, and the same side people will see thousands of years from now. The far side of the moon, the part we never see directly, remained completely unknown until spacecraft finally captured images of it. And even now it feels a little hidden, a reminder that even something so familiar can still hold parts we don't fully experience. That steady relationship between Earth and Moon has been stable for an incredibly long time, so long in fact that it's easy to assume it will always be that way. The moon rises, the moon sets, the cycle continues. There's comfort in that predictability. But what makes it especially interesting is how little we usually think about the mechanics behind it. We don't feel the moon moving through space at over 1 kilometre per second. We don't sense the gravitational forces holding everything in balance. We just see the result, a calm, steady object tracing its path across the sky. It's like watching the hands of a clock without thinking about the gears inside. And because of that, the moon becomes part of the background of our lives. Something we notice occasionally, admire briefly, and then move on from. But imagine, just for a moment, that you started paying attention to it every single night. Not casually, but deliberately. You look up, same time each evening, and check its position, its size, its brightness. At first, nothing would seem unusual. The moon would continue its familiar cycle, waxing, waning, shifting across the sky in a way that feels almost routine. But then, after a while, you might begin to notice something small, a slight difference. Maybe it seems just a touch larger than you remember. Not enough to alarm you, just enough to make you pause for a second longer than usual. You might shrug it off. After all, the moon does change its apparent size slightly depending on where it is in its orbit. Some nights it appears bigger, some nights smaller. That's normal. But then the next night you notice it again, and the night after that. It's not dramatic. It's not obvious to everyone, but if you're paying attention, it's there. A subtle, steady increase. The moon is getting closer. At first, it might even feel like a curiosity rather than a concern. A slightly larger moon means brighter nights, more defined shadows, a sky that feels just a bit more alive. People might start pointing it out more often. Have you seen the moon tonight? It becomes a small topic of conversation, something shared, something noticed. But over time, that subtle change would continue, and eventually it would reach a point where it's no longer easy to ignore. The moon would look noticeably larger than it used to. Not just compared to last night, but compared to how you remember it from weeks or months ago. And that's when the familiarity begins to shift. Because the moon, which once felt steady and predictable, would start to feel different. Not chaotic, not frightening, at least not yet, but unfamiliar enough to make you think. Something has changed. And even if everything else in your day remains the same, that one quiet presence in the sky would no longer feel quite as ordinary as it once did. It would still rise, it would still set. But now there would be a new awareness attached to it, a sense that it's not just there, it's moving, and it's moving closer. which makes the next question almost inevitable. If the moon continues to approach, what happens to everything it's already been quietly influencing all this time? Continuing from that quiet realization, it helps to shift our attention away from how the moon looks and toward what it does. Because for something that feels so distant and passive, the moon is constantly at work. Not loudly, not in a way that demands your attention, but steadily, gently, and without pause. Even now, as you're listening, whether you're fully awake or already beginning to drift, the moon is pulling on the Earth. You can't feel it directly. There's no sensation, no tug you can notice in your body. But the effect is there, subtle and persistent, shaping one of the most fundamental rhythms of our planet, the oceans. If you've ever stood near the sea and watched the tide come in, you've already witnessed the moon's influence. The slow, patient rise of water, inch by inch, until the shoreline shifts and the waves reach places that were dry just hours before. And then, just as gradually, the water retreats again, out, in, out, in. A rhythm so steady that entire ecosystems have adapted to it. Creatures that live between land and sea rely on it. People who work on the coast plan their days around it. Harbours, fishing routes, even certain traditions, all quietly aligned with this ongoing motion. And at the heart of it is gravity. The moon's gravity pulls on Earth, and because water is fluid, it responds more easily than solid ground. The oceans stretch slightly toward the moon, creating a bulge of water on the side of Earth facing it. But there's also a second bulge on the opposite side, caused by the way Earth and Moon orbit their common centre of mass. It's a bit like a slow, continuous balancing act. As Earth rotates, different parts of the planet move through these bulges, and that's what creates the cycle of high and low tides. Twice a day for most places. It's a quiet system, but an incredibly powerful one. And what makes it even more interesting is that this motion isn't perfectly smooth. The sun also plays a role. When the sun, moon and Earth align during a full moon or a new moon, their combined gravitational pull creates what are known as spring tides. Higher highs, lower lows, a slightly more dramatic version of the usual cycle. When the sun and moon are at right angles during the first and third quarter phases, their effects partially cancel out, leading to nep tides. Gentler, less extreme. So even in something as simple as the rising and falling of the ocean, there's a layered interaction happening. A conversation between celestial bodies, expressed through water, and it's been going on for a very long time. But tides are only one part of the moon's influence. There's another effect, less visible but just as important. Stability. Earth is not perfectly upright as it spins. Its axis is tilted, about 23.5 degrees, which is what gives us seasons. Summer, winter, the gradual shift in sunlight throughout the year. But that tilt is not fixed. Without the moon, Earth's axis would wobble much more dramatically over time. It could shift unpredictably, leading to extreme and unstable climate changes. Imagine a world where the tilt swings wildly, where the poles might point more directly at the sun for extended periods, or where the equator experiences conditions it never has before. It wouldn't be a gentle variation, it would be chaotic. The moon acts as a stabilizer. Its gravitational pull helps keep Earth's tilt relatively steady, preventing those large swings. It's not perfect, the tilt does change slightly over long time scales, but it's controlled, predictable. And because of that, our climate remains relatively stable. Seasons come and go in a pattern we can understand. Ecosystems develop around that pattern. Life in general benefits from that consistency. So in a way, the moon is not just a companion in the sky. It's a quiet anchor, holding Earth's orientation in place, keeping the long-term rhythm of the planet from drifting too far. And then there's another, even slower effect. The moon is gradually slowing down Earth's rotation. This might sound surprising, because we tend to think of days as fixed, 24 hours, steady and unchanging. But in reality, Earth used to spin faster. Hundreds of millions of years ago, a day was shorter. Not dramatically so on a human timescale, but enough that over geological time it adds up. The reason for this slowing is tied to tides. As the moon pulls on Earth's oceans, the movement of water creates friction with the ocean floor and the continents. That friction gradually transfers energy from Earth's rotation to the moon's orbit. In simple terms, Earth's spin is losing a tiny bit of energy, and the moon is gaining a tiny bit of distance. That's why the moon is drifting away from us. About 3.8 centimeters per year. Not something you'd ever notice directly, but measurable with precise instruments. So the relationship between Earth and moon is not static, it's dynamic, slowly evolving. The moon pulls on Earth, Earth pulls on the moon, energy shifts between them, distance changes over time, and yet, from our perspective, it all feels steady. The changes are so gradual that they blend into the background of existence. You wake up, the day passes, the moon rises and sets, the tides come and go, everything feels consistent. But now, let's gently return to the thought we introduced earlier. What if that balance begins to change? Because everything we've just talked about, tides, stability, the slowing of Earth's rotation, all of it depends on one key factor: distance. The strength of gravity depends heavily on how far apart two objects are. If the distance decreases, the gravitational pull increases, not linearly, but significantly. So if the moon begins to move closer, even slowly, its effects don't just increase a little, they increase more noticeably. At first, the changes would still be subtle. Tides would grow slightly stronger. High tides a bit higher, low tides a bit lower. Coastal areas might notice earlier than inland regions. People who track tides closely, fishermen, sailors, researchers, would begin to see patterns that don't quite match historical expectations. But for most people it would still feel normal. The ocean always moves, after all. A slightly stronger tide doesn't immediately signal something unusual. But over time, as the moon continues its approach, that gentle increase becomes harder to ignore. High tides begin to reach farther inland. Shorelines shift more noticeably. Places that rarely experience flooding might start to see occasional water encroachment during peak tides. And because this is happening gradually, it doesn't arrive as a sudden shock. It creeps in. A little more water than expected one day. A slightly higher reach the next week. Until eventually, the pattern becomes clear. The tides are changing, and they're not returning to what they used to be. At the same time, the stabilizing effect of the moon would begin to shift. This part is more complex, and it wouldn't be immediately noticeable in daily life. Changes in Earth's axial stability happen over longer timescales, but the system itself would no longer be in its usual balance. The gravitational relationship that keeps Earth's tilt steady would be adjusting, responding to the moon's new position. It's not that the axis would suddenly wobble wildly overnight, but the long-term behaviour of the planet would begin to move away from the stability it has enjoyed for so long. And all of this, the tides, the stability, the slow exchange of energy, is happening quietly. No sound, no visible force pulling at the surface of the Earth in an obvious way. Just a gradual increase in influence. The moon, which once felt like a distant observer, becomes a more active participant. Its presence grows, not just visually but physically. And perhaps the most interesting part is that this wouldn't feel like a single dramatic event. It would feel like a series of small changes, each one easy to explain on its own, each one subtle enough to accept at first, but together forming a pattern that becomes harder and harder to ignore. The moon is closer, its pull is stronger, the balance is shifting, and everything that once depended on that quiet, steady distance is beginning to adjust. Which leads us naturally to the next question. If the moon keeps moving inward, what exactly is holding it there in the first place? And what happens when that balance, the one that has kept it safely in orbit for billions of years, starts to break? Look up at the moon on any ordinary night, and it's very easy to assume that it's simply hanging there, not moving in any meaningful way, not going anywhere in particular, just fixed in place, like a decoration carefully positioned in the sky. That impression is understandable. From our perspective on the ground, the moon seems calm and predictable. It rises, it sets, it shifts a little each night. But nothing about it feels urgent or unstable. It doesn't rush across the sky. It doesn't dart or wobble. It follows a path that feels smooth and familiar. But that calm appearance hides something much more dynamic, because the moon is not standing still at all. In fact, it's moving constantly. Fast enough that, if you could somehow watch it from a distance with the right frame of reference, you'd see it tracing a continuous path through space at over 1 kilometre per second. That's more than 3,600 kilometres per hour. Not exactly drifting. And yet, despite that speed, it never flies away into space. It also doesn't fall down onto Earth. Instead, it remains in this steady, looping motion around our planet. Which brings us to a simple but important question. What exactly is keeping it there? The answer begins with gravity. Gravity is often described as a force that pulls objects toward each other. And while that's true, it helps to think of it less as a sudden pull and more as a constant influence. A quiet, ongoing attraction between anything that has mass. Earth has a lot of mass. The moon has less, but still enough to matter. And because of that, they are always pulling on each other. Right now, at this very moment, Earth is pulling the moon toward itself. If nothing else were happening, the moon would simply fall straight down toward Earth, much like an apple falls from a tree. But that's not what we see. The moon doesn't drop. It stays in orbit, and that's because of its motion. The moon is not just being pulled inward, it's also moving sideways, very fast. Imagine for a moment throwing a ball. If you toss it gently, it travels a short distance and then falls to the ground. If you throw it harder, it goes farther before gravity pulls it down. Now imagine throwing it so fast that, as it falls, the ground beneath it curves away at the same rate. The ball keeps falling, but it never hits the ground. It just keeps missing. That's essentially what the moon is doing. It is constantly falling toward Earth under the influence of gravity, but its sideways motion is fast enough that it keeps missing the planet, tracing out a curved path instead of a straight line. That curved path is what we call an orbit, so the moon is not suspended in place. It's in continuous motion, always falling, always moving forward, held in a delicate balance between two tendencies: gravity pulling it inward, motion carrying it forward. If either of those changed significantly, the balance would break. If the moon slowed down enough, gravity would win, and it would begin to spiral inward toward Earth. If it sped up too much, it could escape Earth's pull entirely and drift off into space. But right now, it sits in a kind of equilibrium. Not perfectly static, but stable enough that, over human timescales, it feels unchanging. That stability is what allows us to treat the moon as a constant. We build calendars around it. We predict its phases. We expect it to behave in a certain way, and for the most part it does. But that balance is not as rigid as it might seem. It's maintained by a very specific set of conditions. The moon's current speed, its distance from Earth, the strength of Earth's gravity. All of these factors work together to keep the orbit stable. Change one of them, even slightly, and the path begins to shift. Now, in the real world, these changes happen very slowly. As we mentioned earlier, the moon is gradually moving away from Earth, due to the transfer of energy from Earth's rotation into the moon's orbit. This outward drift is incredibly slow, just a few centimeters per year. But over millions of years, it becomes significant. The moon we see today is farther away than the moon that existed when dinosaurs walked the Earth, and it will continue to drift outward in the future. So the natural direction of change is actually away from Earth, not toward it. Which makes our scenario, the moon moving closer, something that requires a disruption. Because for the moon to begin falling inward, something would need to alter that balance. Something would need to reduce its orbital energy. You can think of orbital energy as the combination of motion and position that keeps the moon in its current path. It's what allows it to keep missing Earth rather than falling into it. If that energy decreases, the orbit becomes smaller. The Moon would begin to spiral inward, not in a straight line, but in a tightening path, gradually drawing closer with each pass. At first, the change would be subtle. The Moon's orbit would become slightly less circular, perhaps a bit more elongated. Its distance at certain points would decrease. Astronomers would notice the difference quickly. Precise measurements would show that the Moon is no longer following its expected path, and over time the inward trend would become clear. The Moon is losing altitude, in a sense, getting closer with each orbit. Now, what could cause something like that? There are a few possibilities, though all of them are unlikely. A large impact, for example, could alter the Moon's velocity. If a massive asteroid struck the Moon in just the right way, it could reduce its sideways speed enough to begin this inward spiral. Another possibility is a gravitational interaction with another large object passing nearby. Something massive enough to tug on the Moon and disturb its orbit. These kinds of events are rare, very rare, but not impossible on cosmic timescales, and if such a disturbance occurred, the result would not be immediate catastrophe. Instead, it would set the stage for a gradual process. The Moon would begin to follow a new path, still orbiting Earth, but on a trajectory that slowly brings it closer. Each orbit slightly smaller than the last, each pass a little nearer, and with each reduction in distance, the gravitational interaction between Earth and Moon would grow stronger. Which brings us back to the balance, because the closer the Moon gets, the more intense the forces become. Gravity increases, tidal effects strengthen. The system that once felt stable begins to shift into something more active. But here's something interesting to consider. Even as the Moon moves closer, it wouldn't simply fall straight down. The orbit would persist, it would just shrink. The Moon would continue circling Earth, but at a decreasing distance, like a slow spiral tightening over time. And as that happens, the speed of the Moon would actually increase. This might seem counterintuitive at first. You might expect that something falling inward would slow down. But in orbital motion, the opposite is true. As the Moon moves closer to Earth, it has to move faster to maintain its orbit. Gravity pulls more strongly, and the balance shifts, requiring greater speed to keep missing the surface. So the Moon's journey inward would not be a slow drift in the sense of motion. It would be a tightening, accelerating orbit. Faster passes, stronger gravitational effects, a system becoming more energetic as it contracts, and all of this would unfold over time, not instantly, not in a single dramatic moment, but as a process, a progression. At first, it would be something only scientists notice, then something more people begin to observe, the Moon appearing slightly larger, the tides becoming more pronounced, the data confirming what the eye begins to suspect. The orbit is changing, the balance is no longer what it was, and perhaps the most unsettling part is that nothing about the sky would look chaotic at first. The Moon would still rise, still set, still follow a path across the sky. But underneath that familiar motion, the underlying dynamics would be shifting. The harmony between gravity and motion, the balance that has held for billions of years, would be adjusting, not broken yet, but no longer perfectly stable, and once that shift begins, it doesn't easily reverse. The system continues to evolve, the orbit continues to shrink, the Moon continues its gradual approach. Some evenings don't feel any different at all. You go about your usual routine, maybe glance outside for a moment, and the sky looks exactly as you expect it to. The same familiar darkness, the same quiet spread of stars, and somewhere among them, the Moon, steady and unremarkable at first glance. Nothing urgent, nothing dramatic. But small changes rarely announce themselves. They begin quietly, almost politely, in ways that are easy to overlook unless you're paying very close attention. And in this case, the first signs wouldn't arrive as anything alarming. They would arrive as slight inconsistencies, the kind that don't quite demand an explanation right away. Astronomers, of course, would notice first. They rely on precision. The position of the moon in the sky isn't guessed, it's calculated down to exact coordinates. Its timing, its path, its relationship to the stars, all of it is mapped and predicted with remarkable accuracy. So when something doesn't line up perfectly, even by a small margin, it stands out. At first, it might be dismissed as a minor error, a calibration issue, a tiny misalignment in instruments, nothing that couldn't be explained with a bit of routine adjustment. But then it happens again and again. The moon appears just slightly off from where it should be, not by much, not enough for anyone without instruments to notice, but enough to raise a quiet question. Why is it drifting? That question wouldn't immediately lead to concern. In science, small anomalies are common. Most of them turn out to be nothing more than measurement quirks or natural variations that fall within expected limits. But this one would behave differently, because instead of staying small, it would grow. Day by day, the difference becomes more consistent. The moon arrives a little earlier than predicted, or a little later. Its position relative to background stars shifts just a bit more than expected, and slowly, the explanation becomes harder to dismiss. Something is changing in its orbit. Now, for most people, this phase would pass completely unnoticed. Life would continue as normal. The moon would still rise in the evening sky. It would still change phases. It would still look, at a glance, exactly as it always has. But then, over time, something more visible would begin to emerge. Not a sudden transformation, just a small visual detail that starts to feel slightly off. You might notice it without being entirely sure. Perhaps one night you look up and think, that seems a bit larger than I remember, and then you move on. Because the moon does change its apparent size slightly throughout its orbit. That's normal. Some nights it's closer, some nights it's farther. There's even a name for when it appears a bit bigger, a supermoon. It happens regularly enough that most people are familiar with the idea. So at first, that subtle increase in size wouldn't feel unusual, but then the next night it still looks large, and the night after that it doesn't seem to shrink back the way you expect. Instead, it holds that slightly enlarged presence, and then, gradually, it becomes just a little more noticeable, still not dramatic, but enough that, if you've been paying attention over several nights, you begin to sense a pattern. The moon isn't just varying in size, it's increasing, slowly, consistently, and that's when something shifts in how we perceive it. Because familiarity depends on consistency. The moon has always changed in predictable ways. Its phases follow a pattern. Its size fluctuates within known limits. Its path across the sky feels reliable. But when those patterns begin to drift, even slightly, the sense of comfort begins to loosen. At this stage, conversations would start to change, not in a dramatic, alarmed way, more like casual observations. Has the moon been looking bigger lately? It seems brighter than usual. Maybe it's just me, but it feels different. These are the kinds of comments that float around before anything is fully understood, and for a while, they would remain just that. Observations without urgency, because the change is still gentle. The moon is not racing toward Earth. It's not visibly moving from one position to another in a single night. It's simply not behaving exactly as it used to. Now, alongside this visual change, there would be other, slightly more technical clues. The brightness of the moon would begin to increase, not because it's producing more light, but because it's closer. A closer object reflects more light toward us. So the night sky would gradually become brighter. Again, not suddenly, but enough that, over time, you might notice shadows becoming a bit sharper. Outdoor spaces appearing slightly more illuminated during full moon nights. The kind of difference that feels subtle at first, but becomes more apparent when compared to memory. And then there's timing. The moon doesn't rise at the same time every night. It follows a shifting schedule based on its orbit. But as that orbit begins to change, the timing would drift away from what we expect. Schedules based on lunar cycles, whether scientific, cultural, or even casual, would begin to feel slightly out of sync. The moon might appear earlier than anticipated, or linger longer in certain parts of the sky. Nothing chaotic, just different. And as days turn into weeks, the accumulation of these small changes would start to form a clearer picture. The moon is not where it used to be, it's closer, and it's continuing to approach. Now, at this point, the idea would begin to move beyond quiet observation, because once a pattern becomes undeniable, it invites explanation. Scientists would analyze the data more deeply, models would be updated, calculations refined, and eventually the conclusion would become unavoidable. The orbit is shifting inward. The moon is gradually losing altitude in its path around Earth, and while that might sound dramatic when stated directly, the experience of it would still feel slow. There would be no immediate sense of urgency. The distances involved are still vast. Even after noticeable changes, the moon would remain far enough away that nothing catastrophic is happening yet. But the trend is what matters, because it's not just that the moon is closer, it's that it's continuing to get closer. And once that realization settles in, it changes how people look at the sky. What was once a passive background presence becomes something you check more deliberately. You look up not just out of habit, but out of curiosity. You compare what you see to what you remember. You notice differences. And perhaps most importantly, you begin to wonder what comes next. Because the moon is not just a visual object, it has influence. We've already talked about how it affects tides, how it stabilizes Earth, how it interacts with our planet in ways that are constant but usually subtle. But as distance decreases, those influences grow stronger, and while the earlier signs are visual, size, brightness, position, the next stage begins to shift from what we see to what we experience. Because the closer the moon gets, the more its gravitational pull begins to make itself known in ways that are harder to ignore. At first, the changes are gentle, then they become noticeable, and eventually they become something that reshapes the environment itself. If the moon is no longer in a stable orbit, and its path is slowly bringing it closer with each pass, what would be the very first clear signs, the ones we could see with our own eyes, that something is truly different? On some nights, the difference would still be easy to dismiss. You might step outside, glance upward, and everything would seem familiar enough that your attention drifts elsewhere. The sky still holds its usual shape. The stars are where they should be. The moon is present, calm and steady, just as it has always appeared. But then there are moments when something feels slightly off. Not dramatically wrong, just not quite the same. And that feeling, that quiet sense that something isn't lining up with memory, would be one of the earliest signals that something is truly changing. At first, most people wouldn't have the words for it. They wouldn't say, the moon's orbit is decaying, or its trajectory is shifting inward. Those are the kinds of explanations that come later, once the data has been studied and confirmed. Instead, the first signs would show up as small observations, the kind that feel more like impressions than conclusions. The moon seems brighter tonight. It feels larger than it used to. The night doesn't look quite as dark. These thoughts might pass through your mind briefly, and then fade. Because the moon does vary naturally. Its brightness changes with its phase. Its size fluctuates slightly depending on its position in its orbit. These are things we've all seen before, even if we haven't thought about them in detail. So at first there's no immediate reason to be concerned. But what makes this situation different is not any single observation, it's the consistency. Night after night, the same subtle differences begin to repeat. The moon doesn't return to what you remember as normal. Instead, it continues in the same direction. A little larger, a little brighter, a little more present in the sky. And slowly, almost without realizing it, people begin to notice. Not everyone at the same time, not in the same way, but enough that the conversation starts to grow. Someone points it out casually, another person agrees, a photo gets compared to one taken weeks earlier, and the difference becomes easier to see. The moon is changing. Now, alongside these visual clues, there would be another set of signs, ones that don't rely on looking up at the sky, signs that come from the Earth itself. Because as the moon moves closer, its gravitational influence becomes stronger, and while we don't feel gravity directly in our bodies, we do see its effects, especially in water. Coastal regions would begin to notice changes first. At first, it might appear as slightly higher high tides. Nothing alarming, just a bit more water reaching a bit farther than expected. Something that might be attributed to weather, or seasonal variation, or even simple coincidence. But then it happens again and again. The pattern begins to form. High tides consistently exceed previous levels. Low tides drop further than usual. The range between them grows, and importantly, it doesn't return to what it used to be. For people who live near the coast, this would become harder to ignore. Harbours that were once predictable begin to behave differently. Boat schedules shift. Certain areas that rarely flooded might start to see occasional water encroachment during peak tides. Again, nothing catastrophic yet, but enough to raise questions. Why are the tides stronger than they should be? At the same time, scientists monitoring ocean levels would begin to detect clear trends. Tidal data is recorded with precision. It's tracked over long periods, so when something changes beyond expected variation, it stands out. And just like with the moon's position in the sky, the data would show a consistent pattern. The tides are increasing in intensity, and there's only one major factor capable of causing that kind of global, synchronized change: the moon. Now, while coastal areas would feel this shift first, the effects wouldn't stay confined there. Over time, larger tidal movements would begin to influence weather patterns slightly. Ocean currents could be affected. The distribution of heat across the planet might shift in subtle ways. These are not immediate dramatic changes, but they add to the growing sense that something is different. Meanwhile, back in the sky, the visual transformation continues. The moon's size becomes more noticeably larger, not just compared to memory, but compared to recent nights. If you were to take a photograph of the moon each evening and place them side by side, the progression would become clear. A steady increase, not sudden, but undeniable. And with that increase comes brightness. Full moon nights would begin to feel almost unusually illuminated. Shadows sharper, more defined. Outdoor spaces that once felt dim under moonlight would now feel more exposed. The difference wouldn't be overwhelming, but it would be noticeable. Enough that people might comment on it without quite understanding why. It's really bright tonight. It almost looks like daylight out there. And gradually the tone of these observations would begin to shift, from curiosity to concern. Because as more information becomes available, as scientists analyze the data and confirm what's happening, the explanation would become clearer. The moon is moving closer, its orbit is no longer stable, and that realization would spread, not instantly, not all at once, but steadily. Through news, through conversations, through the accumulation of shared observations. At first, the idea might feel distant. After all, the moon is still far away. Even if it's closer than before, it's not suddenly looming overhead. There's still space between us, still time. But the key difference is this: the change is not stopping, it's continuing, and that makes it different from anything we're used to. Because most natural variations we experience eventually return to a baseline. Tides rise and fall, but they stay within a range. The moon appears larger and smaller, but within limits. Weather shifts, but cycles back. In this case, there is no return, only progression, and that progression becomes more noticeable with each passing night. The moon grows, the tides strengthen, the data confirms what the eye begins to see. And perhaps most importantly, the familiarity begins to fade. The moon no longer feels like a passive background object. It becomes something active, something changing, something that demands attention. You might find yourself looking up more often, not just out of habit, but out of curiosity, checking its size, its brightness, its position, comparing it to what you remember, and each time noticing that it's just a little more different than before, not enough to panic, but enough to think something is wrong. And once that thought takes hold, it's hard to ignore, because every night offers a new confirmation. The moon is closer than it was, and it's still coming. Once the signs are no longer subtle, once the differences become clear even without careful observation. What happens when the moon's approach becomes something no one can overlook? At some point, the difference would stop being something you have to look for. It would simply be there. Obvious, present, impossible to miss. You wouldn't need to compare photos anymore. You wouldn't need to rely on memory or careful observation. A single glance at the sky would be enough to tell you that the moon is not where it used to be. It's larger, not slightly. Not in a way you could explain away as a normal variation, but noticeably larger, in a way that feels unfamiliar the moment you see it. And once that threshold is crossed, something changes in how people react. Because up until now, the situation has been gradual, subtle enough that it invites curiosity more than concern. But when something becomes immediately visible to everyone, without explanation, without effort, it becomes harder to treat it as background. The moon would begin to feel present in a different way, more dominant, more immediate. If you've ever seen the moon low on the horizon, when it appears unusually large due to perspective, you might have experienced that strange feeling. It doesn't look threatening, but it does look different enough to catch your attention and hold it for a moment longer than usual. Now imagine that effect, but not limited to the horizon. Imagine the moon appearing that large when it's high in the sky, centered above you, clear, detailed, and undeniably closer. That's when the shift becomes real, and it wouldn't just be about size. The moon's surface would begin to reveal more detail to the naked eye. The dark patches, the lighter highlands, the boundaries between them would become sharper, more defined. Features that once required binoculars or a small telescope might start to become visible without any aid. You might notice patterns you've never seen before, subtle textures, variations in brightness. The moon would begin to feel less like a distant object and more like something with visible structure. Still far away, but no longer abstract, and with that increased clarity comes brightness. Full moon nights would begin to feel unusually illuminated. Not quite like daylight, but enough that darkness loses some of its depth. Outdoor spaces would take on a clearer, more defined appearance. Shadows would sharpen, edges would stand out. It would feel as though the night itself has changed slightly. Again, not overwhelming, but noticeable. Enough that people begin to talk about it more openly. Not just in passing comments, but in conversations that carry a different tone. Because by now, the explanation is no longer uncertain. It's widely understood. The moon is moving closer, its orbit is shrinking, and that process is continuing. At this stage, the idea becomes part of everyday awareness. You don't need to follow scientific reports to know something is happening. You can see it every night. And because the change is ongoing, the experience becomes something you track over time. You notice how the moon looked last week. You compare it to how it looks tonight. You begin to anticipate how it might look tomorrow. It becomes a reference point again, but not in the quiet, predictable way it once was. Now it's a marker of change, a visible reminder that something is evolving. Now, alongside these visual changes, the physical effects on Earth would continue to grow. The tides, already stronger than before, would become more pronounced. Coastal areas would begin to experience higher surges during peak tides, water reaching farther inland than it typically does. Not everywhere at once, not all the time, but often enough that it becomes part of the pattern. And because this is happening gradually, people would begin to adapt. Temporary barriers might be set up, schedules adjusted, precautions taken. At first, these would be small responses, localized, manageable. But they signal something important. The moon's influence is no longer just a background process. It's becoming something that affects daily life in more direct ways. And yet, even with these changes, there would still be a sense of time. The moon is closer, yes, but it's not here. There is still distance, still space between Earth and the moon, still time before anything more extreme happens, which makes this phase particularly interesting, because it's a period where awareness is high, but immediate danger is still low. People know something is happening, they can see it, they can measure it, but they're still living within a world that feels mostly familiar. The sky is different, but the ground beneath their feet hasn't changed dramatically yet. The days continue, the routines continue, life continues, just with a new presence overhead, and that presence would continue to grow. Night after night, the moon's size increases, its brightness intensifies, its position in the sky becomes something you can't ignore, even if you try. It would dominate the night, and perhaps the most striking part is how consistent the progression would feel. There wouldn't be sudden jumps, no abrupt leaps in distance, just a steady, ongoing approach, which means that each night becomes a kind of comparison point. You look up and think, it's closer than yesterday, and you're right. Not by a huge amount, but enough to notice, enough to feel. Now as the moon continues this inward path, something else begins to shift. Not just in the oceans, not just in the sky, but in the way gravity itself is acting between Earth and moon. Because as distance decreases, gravitational forces don't just increase linearly, they increase more significantly, which means that the closer the moon gets, the more rapidly its influence begins to grow. At first, the changes were slow. Now, they begin to accelerate. The tides grow stronger more quickly. The moon's apparent size increases more noticeably over shorter periods. The system is becoming more active, more responsive, more intense. And yet, from a human perspective, it still unfolds over time. Enough time to observe, enough time to think, enough time to wonder what happens next. Because up until now, the changes have been visible, measurable, but still manageable. The sky looks different, the oceans behave differently, but the Earth itself remains largely stable. That won't always be the case, because as the moon continues to draw closer, its gravitational pull will begin to affect not just water, but the planet more directly. The forces involved will start to interact with Earth in ways that are harder to ignore, which raises the next question naturally. What happens when its presence starts to affect the most responsive part of our planet? Long before anything dramatic happens in the sky itself, the oceans would begin to tell the story. Not all at once, and not in a way that immediately feels catastrophic, but in a steady, growing departure from what people along the coast have always known. The familiar rhythm of the sea, something that has been reliable for generations, would begin to stretch beyond its usual limits. At first, it would still feel like a variation. High tides would come in just a little higher than expected. The kind of difference that might be noticed by someone who visits the same shoreline every day. Someone who knows exactly where the water usually reaches. A rock that is normally dry might be covered for a little longer. A strip of sand might disappear a bit earlier than usual. Nothing alarming, just different, and easy to explain away. Weather perhaps, a passing storm far out at sea, a seasonal fluctuation. These things happen. The ocean is never perfectly still, never perfectly predictable, but then the pattern repeats, and not just in one place. Across different coastlines, in different parts of the world, people begin to notice the same thing. The tides are running higher than they should. Not once, not twice, but consistently. And consistency changes how we interpret things. Because when something happens again and again, in a way that doesn't return to normal, it becomes harder to attribute it to coincidence. It becomes a signal. At this stage, scientists monitoring ocean levels would already have a clear picture. Tide gauges, satellite measurements, long-term records, all of them would show the same trend. The amplitude of the tides is increasing, and the cause would no longer be in question. The moon is closer, its gravitational pull is stronger, and the oceans are responding. Water, after all, is the most responsive part of our planet when it comes to gravity. It doesn't resist or hold its shape the way land does. It moves, it shifts, it stretches under the influence of external forces, so as the moon draws nearer, that stretching becomes more pronounced. The bulges of water that define high tides grow larger, the dips that define low tides grow deeper, and the cycle continues, but with greater intensity. Now, this doesn't mean that every high tide immediately becomes a flood. The increase is still gradual, but the range between high and low tide expands, and that expansion has consequences. Coastal areas that are used to a certain rhythm begin to experience water levels that exceed previous expectations more frequently. Places that only saw occasional flooding during rare conditions might begin to see it more regularly. Harbours would become harder to manage. Boat moorings would need adjustment. Infrastructure built with a certain tidal range in mind would start to feel the strain. Again, not all at once, but enough to be noticed, enough to require adaptation. Now, as the moon continues its approach, the rate of change would begin to increase. Because gravitational force doesn't just increase steadily with proximity, it strengthens more rapidly as distance decreases. So what started as a gentle rise in tidal intensity would begin to accelerate. High tides would push farther inland. Low tides would expose more of the seabed than usual. In some places, the shoreline itself would begin to shift in a noticeable way. Beaches might narrow, coastal vegetation could become stressed by more frequent exposure to salt water, and in areas with shallow coastal gradients, where the land slopes gently into the sea, even a modest increase in tidal height can translate into a significant horizontal movement of water, which means that the ocean doesn't just rise, it spreads. Now, alongside this, there would be another effect, one that's less immediately visible but just as important. The movement of water itself would become more energetic. Stronger tides don't just mean higher water levels, they also mean faster currents. Water moving in and out with greater force. This would affect navigation. Ships entering and leaving ports would need to account for stronger flows. Smaller vessels might find certain areas more difficult to manage. Even underwater, the increased motion would influence marine environments. Sediment would be stirred more vigorously. Nutrients would be redistributed differently. Ecosystems that depend on stable conditions might begin to feel the shift. Again, none of this is instant. It unfolds over time, but the direction is clear. The ocean is becoming more active, more responsive, more influenced by the moon's presence. Now, at a certain point, the change would move beyond what could be managed easily. Because as the moon continues to get closer, the tidal forces grow not just stronger, but significantly stronger. And this is where things begin to feel different. Not just unusual, but increasingly difficult to ignore. High tides would begin to reach levels that were previously considered extreme. What once required specific conditions, storms, atmospheric pressure, seasonal alignment, would now occur under normal circumstances. Water would begin to encroach into areas that were not designed to handle it regularly. Coastal defences would be tested more often. Some might hold, some might not. And importantly, the timing of these tides would still follow the moon's position, which means that these higher water levels would arrive in a predictable pattern. But that predictability doesn't make them less impactful. If anything, it makes them something people must plan around more carefully. Daily life in coastal regions would begin to revolve more strongly around tidal schedules. Activities would shift, precautions would become routine, and over time the definition of what is considered normal would change. Now, as the oceans continue to respond, something else begins to happen. The influence of the moon's gravity starts to extend beyond just water. Up until now, the most visible effects have been in the oceans because water moves easily. But Earth itself is not completely rigid. The solid ground beneath us can also respond to gravitational forces, though to a much smaller degree. This is known as Earth tides. Even under normal conditions, the surface of the Earth rises and falls slightly due to the gravitational pull of the moon and the sun. The movement is small, only a few centimeters, and not something we can feel directly. But it exists, and as the moon gets closer, that effect would increase. The planet itself would begin to flex more noticeably. Still not something you would feel in a dramatic way, but measurable. Another sign that the system is shifting, another layer of interaction becoming stronger, and all of this is happening while the moon continues to grow larger in the sky. Brighter, closer, more dominant. The connection between Earth and Moon, once subtle and background, is becoming more active, more visible, more present. Now, it's important to remember that even at this stage we are still dealing with a process, not a single event. There is still time, still progression. But the nature of that progression is changing. The early stages were slow. Now the changes are becoming more noticeable over shorter periods. The system is accelerating, and the oceans, as they often do, are the first to show us just how much that matters. Because water responds quickly. Water reveals change clearly, and as the moon continues its descent, the oceans will continue to reflect that growing influence. There comes a point where the sky itself stops feeling familiar. Not because it has changed suddenly, but because the difference has grown large enough that memory can no longer smooth it over. You don't need to compare it to yesterday, or last week, or even last month. A single glance upward is enough to tell you that something is not as it used to be. The moon now takes up more space in the sky than you've ever seen before. Not in the exaggerated way it sometimes appears near the horizon, where perspective plays tricks on the eye, but in a steady, undeniable way that holds no illusion. Even when it's high overhead, where it normally looks smaller and more distant, it appears large, substantially large. And once you notice that, it becomes difficult to look away. Because the moon is no longer just part of the sky, it is beginning to dominate it. At first, the increase in size felt gradual, something you could track over days or weeks. But now, the changes become easier to detect over much shorter periods. Night to night, the difference is clearer. The moon is closer than it was yesterday, and that realization begins to settle in more deeply, not as a sudden shock, but as a quiet certainty. Now, with that increased proximity, something else becomes more apparent. Detail. The surface of the moon, once soft and slightly blurred to the naked eye, begins to reveal sharper features. The contrast between the darker Maria and the lighter highlands becomes more pronounced. Boundaries that once seemed smooth now appear more defined. You might find yourself noticing patterns you've never paid attention to before. Subtle variations in tone, faint lines and shapes that suggest texture. It's still not like looking through a telescope, but it's closer than it used to be. Close enough that the moon begins to feel less like a distant disk and more like an object with visible structure. And with that clarity comes brightness. The moon reflects sunlight, and as it moves closer, more of that light reaches Earth. Full moon nights begin to feel noticeably different. Not just a little brighter, but enough that darkness itself seems to recede. Outdoor spaces that once relied on artificial lighting begin to feel more illuminated naturally. Shadows sharpen, edges become more distinct. The contrast between light and dark increases. It's not daytime, but it's no longer the kind of night you're used to. There's a steady glow, a presence that fills the sky and spills down onto the ground. And because this change is gradual, people would begin to adapt to it without fully realizing how much things have shifted. At first, it might feel interesting, even enjoyable. There's something appealing about a brighter night. It changes the atmosphere. It alters the way the world looks after sunset. You might notice more people outside looking up, conversations shifting toward the sky more often, photos being taken, shared, compared. Look at how big it is tonight. It's even brighter than yesterday. These observations would spread not as warnings but as shared experiences, because at this stage the transformation still carries a sense of curiosity, but that curiosity begins to take on a different tone as the progression continues, because the moon doesn't stop growing. Each night it becomes just a little larger, just a little brighter. And eventually the change becomes too significant to treat casually. the moon begins to occupy a substantial portion of the sky, not filling it entirely, but large enough that it commands attention in a way it never has before. You can no longer ignore it, even if you try. It's there, visible through windows, above buildings, between trees, a constant presence. And with that presence comes a shift in how the night feels. The sky is no longer a distant backdrop. It becomes something more immediate, more active, more close. Now, alongside the visual changes, the timing of the moon's movement across the sky would also begin to feel different, because as the moon moves closer, its orbital speed increases. It completes its path around Earth more quickly. This means that its position relative to the stars changes at a slightly faster rate. At first, this would be subtle, but over time, it becomes noticeable. The moon seems to move more quickly across the sky than it used to. Its rise and set times shift more noticeably. The familiar rhythm of its cycle begins to change, and once again, this contributes to the sense that something is no longer stable. The patterns people have come to expect are no longer holding. The moon is not just larger, it's behaving differently. Now, as the moon continues its approach, there would also be changes in how it appears during different phases. The crescent moon, for example, would look more dramatic, the curve of light sharper, the illuminated portion more intense. The full moon would be especially striking, large, bright and detailed in a way that feels almost overwhelming compared to what people are used to. And during these full phases, the brightness would reach levels that significantly alter the nighttime environment. In some areas, it might become difficult to see faint stars. The moon's light would wash out parts of the sky. Constellations that were once easily visible might become harder to distinguish. The balance of the night sky would shift. The moon, once one object among many, begins to overshadow the rest. And that in itself changes how people relate to the sky. Because for most of human history, the night sky has been filled with points of light, stars, planets, patterns that people have used for navigation, storytelling, and simple observation. Now, one object begins to dominate that view. Not completely, but enough to alter the experience, and as that happens, the emotional tone begins to shift. Because what started as curiosity begins to carry a sense of weight. The moon is not just interesting anymore, it's becoming significant. Not in a dramatic, alarming way yet, but in a way that is harder to ignore. You might find yourself looking at it longer than usual, not just appreciating it, but thinking about it, comparing it to what you remember, noticing how much it has changed, and realizing that it's still changing. Now, all of this is happening while the physical effects on Earth continue to grow. The tides are stronger, the oceans more active, the data confirming what the eye can see. The system is evolving, and importantly, the rate of change is increasing. The differences from night to night are becoming more noticeable. The progression is accelerating, and that acceleration is key. Because it means that the moon's influence is not just increasing steadily, it's increasing more rapidly over time. Which leads to a new stage in this process. Because as the moon draws closer still, its gravitational pull begins to extend beyond the oceans, and subtle shifts in the Earth's surface. It begins to interact with the planet in ways that are more direct, more structural, more difficult to ignore. The forces involved are no longer confined to water or minor adjustments. They begin to affect the Earth itself in ways that can be felt more clearly. And that raises the next question. When the moon gets close enough for its gravity to start pulling more strongly on the solid parts of our planet, what does that actually look like? What does it feel like? And how does Earth respond when that quiet balance between two worlds begins to strain? Up until this point, most of what we've described has been visible or measurable in ways that feel somewhat familiar. The moon grows larger, the tides rise higher, the sky becomes brighter. All of these things are unusual, but they still fit within patterns we understand. Water moves, light changes, the sky shifts. But the ground beneath your feet, that has always felt steady, reliable, unmoving, and that's where the next stage becomes different. because as the moon continues to draw closer, its gravitational influence doesn't just act on water anymore. It begins to pull more noticeably on the solid Earth itself. Now, this might sound surprising at first. We tend to think of land as rigid, something that doesn't respond to forces in the same way that water does. But in reality, Earth is not perfectly solid. It has flexibility, especially on large scales. Even under normal conditions, the moon causes what are known as Earth tides. The surface of the planet rises and falls slightly by a few centimeters as the moon's gravity pulls on it. It's not something you can feel. It's not something you can see, but it's measurable, and it's happening all the time. But as the moon moves closer, that effect increases. The same forces that were once gentle enough to go unnoticed begin to grow stronger. Not instantly, not in a way that causes immediate disruption, but enough that the Earth itself begins to respond more actively. At first, this would still be subtle. The planet would flex slightly more than before. The rise and fall of the ground would increase, not dramatically, but measurably. Sensitive instruments would detect it. Scientists would observe that the Earth is deforming more under the moon's influence. But for most people, life would continue without any direct sensation. The ground would still feel solid, still stable, still dependable. However, as the moon continues its inward path, the increasing gravitational force becomes more significant, and with that, the strain on Earth's structure begins to grow. Now, the Earth is not a single, uniform piece. Its outer layer, the crust, is divided into large sections known as tectonic plates. These plates move slowly over time, interacting with each other at their boundaries. Under normal conditions, these movements are gradual, but they are also under constant stress, and when additional forces are applied, those stresses can change. As the moon's gravitational pull strengthens, it begins to exert more influence on these systems, not in a sudden, catastrophic way, but in a way that adds to the existing forces already at work within the planet. This could lead to subtle shifts in how stress is distributed along fault lines. In some regions, it might slightly increase the likelihood of movement. In others, it might alter the timing of events that were already building beneath the surface. Now, it's important to keep the scale in perspective. This wouldn't mean immediate global disruption, but it would mean that the Earth is no longer responding only to its internal processes. There is now a stronger external influence acting on it, and that influence is growing. Over time, as the moon gets closer, the deformation of the Earth's surface becomes more pronounced. Still not something that would cause the ground to visibly rise and fall beneath you in a dramatic way, but enough that, over large areas, the shape of the planet is being subtly stretched, pulled slightly toward the moon, and as this happens, the forces involved become more noticeable in indirect ways. For example, the increased gravitational pull would affect how objects weigh. Not dramatically, but measurably. Gravity at the surface of Earth would shift slightly depending on the moon's position. Again, not something you would feel consciously, but something that could be detected with precise instruments. A small variation in the pull you experience, a tiny change in the force holding you to the ground. Now, alongside this, the atmosphere would also begin to respond. Just like the oceans, the atmosphere is fluid. It can be influenced by gravitational forces. Under normal conditions, the moon causes slight atmospheric tides, small shifts in air pressure that are generally too subtle to notice. But as the moon draws closer, those effects would increase. Air itself would begin to move more in response to the moon's position. This could lead to changes in weather patterns, not immediately dramatic but gradually more noticeable. Variations in wind patterns, subtle shifts in pressure systems, another layer of influence being added to an already complex system. And all of this is happening while the moon continues to grow larger in the sky. Brighter, closer, more present. The connection between Earth and Moon, once something that operated quietly in the background, is becoming more active, more dynamic, more influential. Now, as the Moon continues its approach, the rate at which these changes occur would begin to increase, because the closer the moon gets, the stronger its gravitational pull becomes, and not just incrementally, but more rapidly. Which means that the strain on Earth would begin to grow at an accelerating pace. The deformation of the planet would become more significant. The stresses on tectonic systems would become more pronounced. The influence on oceans and atmosphere would intensify. And importantly, these effects would begin to interact with each other. Stronger tides influence coastal regions. Changes in atmospheric patterns influence weather. Shifts in stress within the Earth influence geological activity. It's no longer a set of isolated changes. It's a system becoming more active as a whole. And yet, even at this stage, the experience for most people would still feel like a continuation of what came before. The changes are noticeable, yes, but they are still unfolding over time. There is still a sense of progression, still time to observe, still time to adapt. But that progression is leading somewhere, because there is a limit to how close the moon can get while remaining intact. At some stage in this gradual approach, the story stops being only about Earth. Up until now, most of the changes have been things we experience here, on the surface of our planet. The oceans rise higher, the sky grows brighter, the ground begins to respond in subtle ways. The moon has been the cause, but it has remained whole, unchanged in its structure, still a single object, still intact. But that cannot continue indefinitely, because there is a boundary, not something you can see, not something marked in the sky, but a very real threshold in the physics of gravity, where the relationship between two bodies changes in a fundamental way. This boundary is known as the Roche limit. It's the distance at which the gravitational pull of a larger body, in this case Earth, becomes strong enough to overcome the forces holding a smaller body together, in this case the moon. To understand this, it helps to think about what is actually keeping the moon intact. The moon is held together by its own gravity. Every part of it pulls toward every other part, creating a cohesive structure. Rocks, dust, solid layers, all bound together by the moon's own gravitational force. As long as that internal gravity is stronger than any external force trying to pull it apart, the moon remains whole. But as it moves closer to Earth, something changes. Earth's gravitational pull on the moon is not uniform. The side of the moon that faces Earth feels a stronger pull than the side that faces away. This difference is called a tidal force, the same kind of effect that creates tides in Earth's oceans. At large distances, that difference is small, but as the moon approaches, the difference becomes larger. The near side is pulled more strongly, the far side is pulled less strongly, and that creates stress within the moon itself. At first, that stress is manageable. The moon's own gravity is strong enough to keep everything together, but as the distance decreases, the tidal forces increase rapidly, and eventually they reach a point where the moon's internal gravity is no longer sufficient to hold it intact. That point is the Roche limit. For a body like the moon approaching Earth, this limit is reached at a distance of roughly 18,000 kilometers from Earth's surface. To put that into perspective, the moon currently orbits at about 384,000 kilometers away. So this is much closer, extremely close, but still above the surface. And when the moon crosses that threshold, the nature of the situation changes completely, because at that point, the moon can no longer remain a single solid body. The tidal forces begin to tear it apart. Now, this wouldn't happen instantly. It wouldn't be like the moon suddenly shattering into pieces in a single moment. Instead, it would begin with fractures, cracks forming within the structure, regions of the moon experiencing different levels of stress. The near side being pulled more strongly, the far side lagging behind. Over time, those stresses would exceed the strength of the material, and pieces would begin to break away. At first, these might be relatively small fragments, chunks of rock separating from the surface, dust and debris being pulled into new paths around Earth. But as the process continues, the fragmentation would become more significant. Larger sections of the moon would begin to lose their cohesion, the overall structure would weaken, and eventually the moon would no longer be able to hold itself together as a single object. It would begin to spread out, not in a chaotic explosion, but in a stretching, tearing process. Material from the moon would be pulled into elongated streams, some pieces moving closer to Earth, others drifting outward, all of them still under the influence of Earth's gravity. Now from Earth, this would be an extraordinary sight. The moon, once a solid disk, would begin to change shape. At first, the differences might be subtle, a slight distortion, a sense that the edges are not perfectly smooth anymore. But as the fragmentation continues, the transformation would become more obvious. The moon would appear to stretch, to lose its clean, circular outline. Bright fragments might become visible around it, small points of light, reflecting sunlight, moving in slightly different paths. Over time, the single, familiar shape would give way to something more complex, a collection of pieces still roughly in the same region of the sky, but no longer forming a perfect sphere. And as these fragments continue to move, they would begin to organize into a new structure. Because while the moon is breaking apart, the material doesn't simply scatter randomly. It remains within Earth's gravitational influence. It continues to orbit. But instead of a single body, it becomes a distribution of debris, rocks, dust, fragments of varying sizes, all tracing paths around Earth. And over time, this material would begin to form a ring. A band of debris encircling the planet, not unlike the rings we see around Saturn. From the surface of Earth, this would be visible as a luminous arc across the sky, a continuous structure made up of countless pieces of the former moon, bright, reflective, shifting slowly as the material moves along its orbit. It would be a striking transformation. The familiar moon replaced by something entirely different, a ring system where once there was a single, solid companion. Now, it's worth considering that not all of the moon's material would remain in stable orbit. Some fragments would move inward, pulled closer to Earth. Others might collide with each other, breaking into smaller pieces. The system would be dynamic, evolving. Not a static ring, but one that changes over time. And eventually some of that material would begin to fall toward Earth, but that comes later. At the moment of crossing the Roche limit, the key change is this. The moon ceases to be a single object. It becomes a collection of fragments, a transformation driven entirely by gravity. The same force that once held it in orbit now pulling it apart. And from Earth, this would mark a clear turning point, because up until now the moon has remained recognizable. Larger, brighter, closer, but still the moon. Now that familiarity is gone, replaced by something new, something that no longer behaves like the object we've always known. Once the moon crosses that invisible boundary where its own gravity can no longer hold it together, the process doesn't feel like an explosion. There's no sudden flash, no outward burst that sends everything flying in all directions. Instead, what unfolds is quieter, slower, almost stretched out in time. The moon begins to lose its shape. At first, the changes are subtle enough that you might question what you're seeing. The edges no longer appear perfectly smooth. The outline seems slightly uneven, as if something is pulling at it from opposite sides. And in a way, that's exactly what is happening. Earth's gravity is pulling more strongly on the side of the moon that faces it, while the far side lags just a little behind. That difference, small at greater distances, has now become powerful enough to overcome the moon's internal strength. The result is tension, and then, slowly, separation. Pieces begin to drift away. Not all at once, not in a dramatic cascade, but in a gradual peeling. Small fragments first, breaking free from the surface, pulled into slightly different paths around Earth. From the ground, you might notice faint points of light appearing near the moon. At first, they would be easy to miss, tiny glimmers scattered around the main shape. But over time, those points would multiply. More fragments, more separation, more evidence that the moon is no longer a single solid body. The transformation continues. The once familiar circular disk becomes elongated, slightly distorted, its structure beginning to stretch under the competing forces acting on it. And then, eventually, it reaches a point where the moon can no longer maintain its overall form at all. Larger sections break away, not exploding outward, but sliding apart, each piece following its own orbit, still influenced by Earth's gravity. The moon dissolves into motion. What was once one object becomes many. Now, this is where something interesting happens. Even though the moon is breaking apart, the material doesn't scatter randomly into space. It remains within Earth's gravitational field. Each fragment continues to orbit the planet, but now on slightly different paths. Some pieces move a bit closer, others drift a bit farther. Their speeds vary, their positions shift, but all of them remain bound to Earth. And over time, those countless fragments begin to organize, not by intention, but by physics. Because objects in orbit tend to settle into stable paths. Collisions between fragments break larger pieces into smaller ones. Interactions between them smooth out their distribution. Gradually, the chaotic collection of debris begins to form a more coherent structure. A ring, a broad, flat band of material encircling the Earth. From the surface, this would be unlike anything humanity has ever seen. Instead of a single moon rising and setting, there would be a luminous arc stretching across the sky. Not always in the same place, not always oriented the same way from every location, but consistently present as a band of light made up of countless particles. Some nights, it might appear as a bright, continuous streak. Other times, you might notice variations, denser regions, gaps, subtle shifts in brightness. It wouldn't be perfectly uniform, but it would be unmistakable. The moon, as we once knew it, would be gone, replaced by something new. Now, the brightness of this ring would depend on the size and distribution of its particles. Larger fragments would reflect more light individually, appearing as brighter points within the structure. Smaller particles, dust and fine debris, would scatter light more evenly, creating a soft glow. Together, they would produce a feature in the sky that is both structured and diffuse. On clear nights, it might appear almost like a pale band stretching across the stars, brighter than the Milky Way, more defined, more immediate, and unlike anything we've ever experienced. The night sky itself would feel different, not just because of the light, but because of the change in structure. The moon has always been a focal point, a single object to look at, to track, to follow as it moves across the sky. Now that focus would be replaced by something broader, a continuous presence, not rising and setting in the same way, but existing as a ring that spans a large portion of the sky. Depending on your location, you might see it arching overhead, or stretching across the horizon, or curving gently from one side of the sky to the other. It would become part of the background, but in a much more prominent way than the moon ever was. And yet, despite its beauty, despite its striking appearance, the ring would not be entirely stable, because the material within it is still moving, still interacting, still evolving. Collisions between particles would continue, larger fragments would break into smaller ones, dust would spread out, filling in gaps. Some material would gradually lose energy and begin to drift inward, and that inward movement is important. Because not all of the moon's remains would stay in orbit indefinitely. Some fragments, especially those that lose enough orbital energy through collisions and interactions, would begin to spiral toward Earth. At first, this might not be immediately noticeable. Small particles entering the atmosphere would burn up, creating streaks of light. Meteors, more frequent than usual perhaps, but still within the realm of natural phenomena. People might notice an increase in shooting stars, a more active night sky. Something interesting, even beautiful. But as time goes on, and as larger fragments begin to lose stability, the situation would change, because not everything would burn up completely. Some pieces, depending on their size and composition, could survive passage through the atmosphere, and that introduces a new layer to the scenario. But before we move into that, it's worth pausing for a moment with the ring itself, because despite everything that led to its formation, despite the forces that tore the moon apart, the result would be something unexpectedly calm in appearance. A steady band of light, a new feature of the sky, something that people would look at, talk about, photograph and try to understand. It would become part of daily awareness, a reminder that something has changed in a fundamental way. The relationship between Earth and its former companion is no longer the same. The moon is no longer a single solid presence. It has become a system, a collection of material still bound to Earth, but no longer unified. While this ring might appear stable from the ground, it is still part of an evolving process. The debris continues to move, continues to interact, continues to change. Some of it remains in orbit, some of it moves outward, and some of it begins to fall inward. And this raises an important question, because while one scenario leads to the moon breaking apart and forming a ring, there is another possibility. What if the moon does not fully fragment? What if enough of it remains intact? Enough of its structure holds together that instead of dispersing completely, it continues its path inward. What does that path look like? There is another way this could unfold, one that feels less graceful. Instead of the moon gradually unravelling into a wide, luminous ring, imagine that much of it manages to hold together. Not perfectly, not untouched, but intact enough that it remains a single dominant mass as it continues moving inward. In this version, the moon doesn't dissolve into a band of debris. It keeps coming, still orbiting, still following that tightening path, but now closer than anything we've ever experienced. And because it hasn't fully broken apart, its influence remains concentrated, focused, more direct. At this stage, the sky would no longer feel like a distant ceiling. It would feel close. The moon would appear enormous, far larger than anything we're used to seeing. Not just a little bigger than a supermoon, but something that occupies a significant portion of the sky. You wouldn't have to search for it. It would dominate your view, even when you're not trying to look at it. Through a window, between buildings, above trees, it would always be there, a constant presence. And with that presence comes a different kind of awareness. Because when something that large appears overhead, it no longer feels like part of the background. It feels like something that matters. Now, as the moon continues its inward path, its orbit would change in another important way. It would become faster. The closer it gets to Earth, the stronger the gravitational pull, and the faster it must move to maintain its orbit. This means that the moon would begin to sweep across the sky more quickly than before. At first, this might be subtle, a slight change in how long it takes to rise and set. But over time, it becomes more noticeable. You might observe that the moon moves more rapidly against the background of stars. Its path feels more dynamic, less like a slow, steady drift, and more like something with momentum. And this adds to the sense that the system is no longer stable. It's evolving. Now, alongside these visual changes, the physical effects on Earth would continue to intensify. The tides, already far beyond their normal range, would become extreme. Water would surge inland during high tides, reaching areas that have never experienced regular flooding. Coastal landscapes would begin to change, shorelines shifting, not over centuries but over much shorter periods. And because the moon remains intact in this scenario, its gravitational pull is not spread out across a ring of debris. It is concentrated, which means the tidal forces are stronger than they would be if the moon had fragmented. The oceans respond more dramatically. The range between high and low tide becomes more extreme. Currents grow stronger. Water moves with more force. And over time, this begins to affect not just coastlines, but entire ocean systems. Now, at the same time, the solid Earth continues to feel the strain. The tidal deformation of the planet increases. The surface stretches more noticeably toward the moon. Again, not in a way that would cause the ground to visibly rise and fall beneath you in a dramatic sense, but enough that the internal stresses within the planet are changing. Tectonic systems respond to these stresses. Fault lines that were already under pressure might shift slightly more frequently. Volcanic activity could be influenced in subtle ways. The planet is no longer operating under its usual balance of internal and external forces. There is now a strong, persistent influence from the moon's proximity, and that influence continues to grow. Now, as the moon draws even closer, something else becomes more apparent. The difference in gravitational pull across the Earth increases. The side of the planet facing the moon experiences a stronger pull than the side facing away. This creates a stretching effect. The Earth is being gently but increasingly pulled into a slightly elongated shape. Again, this is not something that would be visible in a simple way. You wouldn't look at the horizon and see it bending. But the effect exists, and it contributes to the overall strain on the planet. Now, as this process continues, the rate of change accelerates. Because the closer the moon gets, the stronger the forces become, and the more quickly those forces increase. This is an important shift. Up until now, the changes have been gradual, but now each step inward brings a more significant increase in effect. The moon grows larger more quickly. The tides become more extreme over shorter periods. The gravitational strain increases more noticeably. The system is moving towards something. Not a sudden event, but a point where the nature of the interaction changes again. And from the perspective of someone on Earth, this would feel like a growing presence. The moon is no longer just something you observe, it's something you're aware of constantly. You might find yourself looking up more often, not out of curiosity anymore, but out of habit, checking its position, noticing how much it has grown, comparing it to what you remember from just a few days ago, and realizing that the difference is becoming more pronounced. Now, at this stage, the idea of impact begins to feel less abstract. Earlier, it was a distant possibility, something discussed in theory. But now, with the moon so close, so large, so clearly moving inward, it becomes easier to imagine, not as an immediate event, but as a direction, a path that is continuing, and that awareness changes how the situation feels. Because it's no longer about whether something is happening. That part is clear, it's about where it leads. Now, even here, there is still time. The moon is close, but not yet at the surface. It continues to orbit, each pass bringing it nearer, each orbit slightly lower than the last. And as it does, the environment on Earth continues to respond. The oceans grow more active, the atmosphere more dynamic, the ground under increasing stress, all of it building gradually toward the next stage, and that stage is defined by proximity. Because as the moon moves even closer, the time between orbits shortens, the speed increases, the changes from one day to the next become more noticeable, and eventually the approach reaches a point where the moon is no longer just a large object in the sky. It becomes something that feels close in a very real sense. Close enough that the idea of contact is no longer distant. By the time the moon reaches this stage, the idea of distance begins to lose its meaning. It is still above you, still in the sky, but it no longer feels far away. The separation that once made it feel untouchable has narrowed to the point where it becomes something you are constantly aware of, whether you are looking at it or not. It dominates everything. You don't need to step outside to see it. Its light reaches through windows, spills across walls, fills spaces that were once dim at night. Even indoors there is a sense of brightness that doesn't belong to artificial light, something softer, but far more present than anything the moon has ever produced before. And when you do look up, the scale of it becomes undeniable. The moon now fills a vast portion of the sky, not just large, but overwhelming in its presence. Its surface is no longer a smooth disk with faint markings. It is textured, detailed, almost tangible. You can distinguish vast regions, sharp contrasts, subtle shadows across its surface. It no longer feels like something distant. It feels like something near. Now, at this point, the motion becomes more noticeable. The moon is no longer drifting slowly across the sky over the course of many hours. Its movement is faster, more apparent. You could watch it change position in a way that feels immediate, not something that requires patience. Its orbit has tightened so much that each pass around Earth takes significantly less time. Minutes begin to matter. You might glance up, look away, and when you return your gaze, it has shifted more than you expect. Not dramatically from one moment to the next, but enough that your sense of its motion becomes real. It is moving, and it is moving quickly. Now, the gravitational effects at this stage are no longer subtle. The oceans are in a state of constant motion. Tides have long since surpassed anything considered normal. Water surges inland with a force that is difficult to contain. Coastal regions are no longer defined by their usual boundaries. The distinction between land and sea becomes blurred in many places. But even beyond the oceans, the Earth itself is responding more actively. The deformation of the planet increases. The stretching effect, once measurable only with instruments, becomes part of a broader system of stress affecting the surface. Tectonic activity could become more frequent in certain regions. The planet is adjusting, responding to a force far stronger than it was ever meant to experience at this distance. Still, from a personal perspective, much of this would feel indirect. You might hear about it, see the effects. But what you would feel most directly is the presence above you, the moon. It would be impossible to ignore. Even if you tried not to look at it, you would know it's there. Its brightness alone would make that clear. Night would no longer feel like night in the way you remember it. The sky would be dominated by this enormous luminous body, casting light in a way that changes the atmosphere entirely. Stars would fade in its presence. The familiar patterns of the night sky would become harder to see. The moon would take precedence over everything else. Now, as the approach continues, the time between noticeable changes shrinks. Earlier, it took days or weeks to observe a difference. Now, it might take hours. You might notice that the moon appears larger in the evening than it did in the afternoon, that its position feels closer, more immediate, more imposing. The progression accelerates, and with that acceleration comes a shift in how the situation feels. Because at this stage, it is no longer something that can be thought of in distant terms. It is happening now, not at some undefined point in the future, but in the present. The moon is approaching, and it is approaching rapidly. Now, even here, there is still a sequence, still a process. The moon does not simply stop orbiting and drop straight down. It continues to follow its path, but that path is now extremely close to Earth. Each orbit brings it lower, each pass draws it nearer. And the time between those passes becomes shorter, which means that the window between one moment and the next becomes more significant. The changes are happening faster, more noticeably. Now, as the moon reaches its closest approach before impact, its gravitational influence reaches a peak. The difference in gravitational pull across Earth becomes extreme. The side of the planet facing the moon experiences a much stronger pull than the opposite side. This creates a stretching effect that is far beyond anything experienced before. The planet is under strain. The system is no longer in anything resembling its original balance. And yet, from the perspective of someone looking up, what you see is still the moon. Larger than ever, closer than ever, but still recognizable. Still a single object, still following a path. And that familiarity, even at this stage, is what makes the moment feel almost unreal. Because despite everything that has changed, despite the scale, the brightness, the motion, it still looks like the moon, just closer. Now, as the final moments approach, this speed increases further. The moon's motion across the sky becomes rapid enough that it's unmistakable. You can watch it move, not as a slow drift, but as something with clear, visible motion. And at that point, the idea of impact is no longer theoretical, it is imminent. The distance between Earth and the Moon is no longer vast. It is measurable in a way that feels immediate. The separation is closing, and there is no longer time to think of it as something that might happen. It is something that is about to happen. But even here, there is still a brief moment, a final stretch, where the Moon is at its closest visible approach, where its presence fills the sky completely, where its surface details are as clear as they will ever be from Earth. And in that moment, everything is defined by proximity. The Moon is no longer a distant companion. It is no longer even just an approaching object. It is something that is right there, close enough that the boundary between sky and Earth begins to feel thin. For a very brief stretch of time, everything still holds together. The Moon fills the sky so completely that it no longer feels like something above you. It feels like something you are beneath, something close enough that the idea of distance almost disappears. Its surface is no longer a distant pattern of light and shadow. It is structure, texture, vast regions of rock and dust that now feel almost within reach. And then, the motion that has been building all this time reaches its final stage. There is no pause, no hesitation. The Moon does not slow to a stop above Earth. It continues along its path, driven by gravity, by momentum, by the same forces that have been guiding it from the beginning. And then contact begins, not everywhere at once. Because the Earth is curved and the Moon is approaching from a direction, the first interaction happens at a specific region, a point on the planet where the distance between the two bodies becomes zero. At that location, the surface of the Moon meets the surface of the Earth. It is not like two solid objects gently touching. Both bodies are moving. Both carry immense energy. And when they meet, that energy has to go somewhere. The first contact is an impact, an enormous release of energy concentrated in a single region. The material at that point does not remain solid for long. The force involved is so great that rock behaves differently. It doesn't simply crack or break. It compresses, heats, and transitions rapidly into a state that is part solid, part liquid, part vapor. The ground at the point of impact is driven downward. The Moon's surface is driven inward. The energy of motion is converted into heat, pressure, and shock. Now, this initial contact is only the beginning, because the Moon is not a small object. It is thousands of kilometers across, and it is still moving, which means that the region of interaction expands rapidly. What begins as a single point becomes a growing area of contact. The Moon continues to press into Earth. Material from both bodies is displaced. The surface of the planet cannot absorb this force quietly. Shock waves propagate outward from the point of impact, through the ground, through the atmosphere, through the oceans. These are not ordinary waves. They are waves of pressure, moving at incredible speeds, carrying energy across vast distances. From the perspective of someone far from the initial impact site, the first sign would not be the contact itself. It would be the arrival of these waves, a sudden, powerful movement of the ground. Not a gentle tremor, but something much more intense. The Earth responding to an event far beyond anything in its recent history. Now, at the point of contact, the interaction continues. The Moon does not simply stop when it touches Earth. It continues to move inward, driven by its momentum. But as it does, it begins to lose that momentum, because it is encountering resistance. The material of Earth pushes back. The Moon's forward motion is slowed. But the energy involved is so large that this slowing happens over a very short time, and the effects are immense. As the Moon penetrates deeper, more material is displaced. Vast amounts of rock and debris are ejected outward. Some of it is thrown into the atmosphere. Some of it is launched into space. The boundary between Earth and Moon becomes a region of intense mixing. material from both bodies interacting, colliding, fragmenting. Now, it's important to understand that this is not a clean, simple collision. It is a complex interaction. The Moon does not remain intact as it enters Earth. The forces involved begin to break it apart further. Sections of the Moon are compressed, heated, and disrupted. The structure that held it together is overwhelmed. At the same time, the Earth's surface is undergoing extreme changes. The region of impact becomes a zone of intense transformation. The ground is no longer stable. It is being reshaped by the energy of the collision. Now, as the interaction continues, the scale of the event becomes global. The shock waves move outward, reaching farther and farther from the initial point. The atmosphere responds as well. Air is displaced, compressed, heated. Pressure waves travel through it, spreading the effects of the impact across the planet. From a distance, the sky itself would change. The brightness from the collision would be visible, not as a single flash, but as a sustained release of light and energy, because the interaction is not instantaneous. It unfolds over a period of time, still rapid on a human scale, but not a single moment. Now, as the Moon continues to interact with Earth, its identity as a separate object fades. It is no longer meaningful to think of it as the Moon in the way we once did. It has become part of a larger process, a merging. Material from the Moon becomes part of the Earth's surface and surrounding environment. Some of it remains near the point of impact. Some of it is carried outward. Some of it escapes into space. The system is no longer two bodies interacting. It is one evolving system. Now, from the perspective of the planet as a whole, the effects continue to propagate. The energy released does not remain localized. It spreads through the ground, through the oceans, through the atmosphere. Each of these systems responds in its own way, but all of them are affected. Now, even after the initial contact phase, the process is not over, because the Moon's mass is still interacting with Earth. Sections that have not yet fully merged continue to move inward. The interaction continues. Energy continues to be released, material continues to be displaced, and gradually the motion of the Moon is brought to a halt, not because it has stopped on its own, but because its energy has been absorbed into the Earth, converted into other forms: heat, motion, deformation. The momentum that carried it inward is redistributed throughout the system, and once that happens, the distinct movement of the Moon ceases. There is no longer an object approaching. There is only the result of that approach. Now, in the immediate aftermath of this moment, the Earth is not the same as it was before. The surface has been reshaped. The distribution of material has changed. The systems that make up the planet, oceans, atmosphere, crust, are all responding to a sudden and immense input of energy. But those are the next stages. Because the moment of impact, as dramatic as it is only one part of the overall process. It is the point where everything that has been building finally converges, where motion becomes contact, where distance becomes zero, and where the relationship between Earth and Moon is transformed completely, from two separate bodies into something new. What follows does not arrive as silence. There is no pause after impact, no moment where everything settles and becomes still. Instead, the energy released continues to move, to spread, to reshape everything it touches. The Earth, which only moments ago experienced the point of contact, now begins to feel the full extent of what that contact has created. The first thing that travels outward is pressure. Shock waves move through the ground, not as gentle vibrations, but as powerful pulses that carry enormous amounts of energy across vast distances. They do not stay near the impact site. They move quickly, crossing continents, passing beneath oceans, reaching places that were once far removed from the original event. From the perspective of someone far away, the ground would begin to move, not gradually, not in the way small tremors build, but suddenly, a force travelling through the planet itself, arriving with little warning, causing the surface to shift in a way that feels immediate and unmistakable. these waves would not be uniform. Some would travel faster, some slower, interacting with the structure of the Earth as they move. They would reflect, overlap, and interfere with each other, creating complex patterns of motion across the planet. The result is not a single, simple movement. It is a sequence, a series of pulses, each carrying energy from the original collision, each contributing to the overall effect. Now, alongside the movement of the ground, the atmosphere begins to respond. The impact has displaced vast amounts of air, compressed it, heated it, and just like the ground, that disturbance spreads outward. Pressure waves move through the atmosphere, carrying the effects of the collision across the sky. These are not ordinary winds. They are powerful, moving fronts of air that expand outward from the point of impact, affecting regions far beyond where the moon first made contact. From a distance, the sky itself would appear to change, not just in brightness, but in motion. Clouds displaced, air moving with unusual force, the environment responding to an event that is still unfolding. Now, at the point of impact and the regions immediately surrounding it, the effects are more intense. The energy released during the collision has converted into heat, a great deal of heat. The material involved, both from the moon and the Earth, has been compressed and heated to extreme levels. Rock behaves differently under those conditions. It does not remain solid in the way we experience it normally. It can melt, it can vaporize, it can exist in states that are difficult to imagine from everyday experience. The region of impact becomes a place where the usual distinctions between solid, liquid, and gas begin to blur. Material is transformed, not in a controlled or gradual way, but in response to the immense energy involved. Now, as this heated material interacts with the surrounding environment, it begins to spread. Some of it is carried outward along the surface, some of it is ejected upward into the atmosphere, and as it moves, it carries heat with it. From a distance, this would appear as a growing region of brightness. Not a single flash, but an expanding area where the sky and the surface seem to glow. The result is not localized, it spreads. Now, beyond the immediate region of impact, the effects are still significant, but they arrive in a different form. The shock waves reach new areas, the atmospheric disturbances move outward, and the environment begins to respond. The ground shifts, the air moves, and the heat carried by material and energy from the impact begins to influence regions far from the original point. At this stage, the planet is no longer in its previous state. It is in transition, responding to the energy that has been introduced. Now, as the shock waves continue to travel, they interact with the structure of the Earth. Different regions respond differently. Some areas might experience more intense movement depending on how the waves pass through them. Others might experience less, but overall the effect is global. The entire planet is involved in this response. Now, as the atmosphere continues to carry the effects outward, something else begins to happen. Material that was ejected during the impact begins to fall back. Some of the debris that was launched upward does not escape. It returns, and as it does, it interacts with the atmosphere. Friction generates heat. The returning material becomes bright as it moves through the air. From the ground, this would appear as streaks of light across the sky, not isolated but numerous, a pattern of returning material that adds to the overall brightness of the environment. Now, this is not a brief event, it continues. The aftermath unfolds over time. The initial impact releases energy. That energy moves through the planet responds, and as it does, the conditions continue to change. The atmosphere carrying heat and material evolves. The ground, responding to stress and movement, adjusts. The oceans, already influenced by the moon's approach, now respond to the additional forces introduced by the impact. All of these systems interact, not independently, but as part of a larger process. Now, from the perspective of someone observing this from a distance, the experience would be defined by change. The environment would not remain constant. It would shift, gradually but noticeably. The sky would not look the same as it did before. The ground would not feel the same. The overall sense of stability that once defined the planet would be altered. Now, it's important to remember that this stage is still part of the immediate aftermath. The energy introduced by the collision is still moving through the system. It has not yet settled. The planet is still responding, and that response continues to unfold. Now, as this process continues, the longer-term effects begin to take shape. Because the energy release does not simply disappear, it changes the state of the planet. It influences its structure, its systems, its behavior, and those changes will continue to develop beyond this immediate phase. But for now, the focus remains on what happens right after the moment of contact. The movement, the heat, the spreading effects that reach across the planet, and the way everything begins to respond to a force that has never been applied in this way before. In the time that follows, the idea of a before and an after becomes very clear. Not in an abstract way, but in the way everything around you begins to look, behave, and feel different from what it once was. The Earth is no longer simply reacting to a single event. It is adjusting to a completely new state. The forces released during the collision do not remain confined to one place. They continue to move through the planet, redistributing energy, altering structures, and reshaping the surface in ways that extend far beyond the original point of impact. The ground, which once felt stable and predictable, is now part of an ongoing process. Large regions of the surface would have shifted, not just in the immediate vicinity of where the moon made contact, but across wide areas as the shock waves propagated and interacted with the planet's internal structure. The crust, already divided into tectonic plates, would respond to this sudden input of energy in ways that differ from its usual slow movement. Some regions might experience more pronounced displacement, others might adjust more gradually, but overall, the configuration of the surface would no longer match what existed before. Mountains, valleys, coastlines, all of these features are shaped over long periods under normal conditions. Here, those processes are accelerated, not by steady forces, but by a sudden and powerful disturbance. Now, the point of impact itself would no longer resemble anything familiar. The surface there would have been transformed completely. Material displaced, heated, and mixed. The distinction between Earth and Moon at that location would no longer exist in a meaningful way. Instead, it would be a region where the materials of both bodies have combined, reshaped by the energy of the collision. From a distance, this would appear as a vast altered area, one that stands apart from the rest of the planet. But even beyond that region, the changes continue. Because the energy release does not simply dissipate, it moves, and as it moves, it affects everything it encounters. Now the oceans, already in a heightened state due to the moon's approach, would undergo further change. The movement of water, influenced by both the impact and the altered gravitational relationship, would no longer follow the patterns that once defined tides. Instead, the distribution of water across the planet would begin to shift. Some areas might see an accumulation, others might experience a retreat. The balance between ocean basins, coastlines, and land would be altered, and because water plays a central role in Earth's systems, these changes would influence other processes as well. Now, alongside the surface changes, the atmosphere continues to evolve. The impact has introduced large amounts of material into the air. Dust, vaporized rock, and other particles that were lifted during the collision begin to spread. Carried by atmospheric currents, these materials move across the planet. At first, they might be concentrated near the impact site, but over time they distribute more widely. The composition of the atmosphere changes, not permanently in all cases, but significantly enough to affect how light passes through it. The sky itself would appear different, not just brighter or darker, but altered in tone. Depending on the distribution of particles, it might appear hazy or dimmed, or even unusually coloured at certain times. Sunlight interacting with this new composition would behave differently, and this adds another layer to the transformation, because it's not just the ground that has changed, it's the air, the environment as a whole. Now, as these changes continue, the concept of stability begins to shift. Under normal conditions, the Earth operates within a set of balances. Energy flows through systems in ways that are understood and predictable over time. But here, those balances have been disrupted. The introduction of a large amount of energy in a short period alters how these systems interact. The planet is moving toward a new equilibrium, but that process takes time, and during that time, the conditions remain dynamic. Now, from the perspective of someone observing this over a longer period, the most noticeable aspect would be the scale of change. This is not a localized event. It is global. Every part of the planet is affected in some way, some regions more directly, others more indirectly. But all of them are part of the same system, and that system is adjusting. Now, it's important to consider that not all changes happen at the same rate. Some effects are immediate. The ground movement, the initial atmospheric disturbances, the displacement of material. Others unfold more gradually. The redistribution of water, the changes in atmospheric composition, the long-term adjustment of the planet's surface. These processes overlap, they interact, and together they define the new state of the Earth. Now, even as this transformation continues, there are still elements of the original planet present. Not everything is erased, not everything is replaced, but the overall structure, the arrangement of features, the behavior of systems, all of these are different enough that the Earth can no longer be described in the same way it was before. It has been reshaped, not in a single, clean step, but through a series of changes that follow from the initial collision. Now, as the planet continues to adjust, the focus begins to shift from the immediate aftermath to the longer-term consequences. Because once the energy has been distributed, once the initial changes have taken place, the Earth begins to settle into its new configuration. And that process involves further evolution. The atmosphere continues to change, the surface continues to adjust, the systems that define the planet continue to respond. Because after the initial reshaping, after the global changes have taken hold, the environment begins to develop in new ways that are influenced by the new conditions created by the collision. What happens to the atmosphere itself as it continues to respond to these changes? How does the air, the sky, the very envelope of the planet evolve in the time that follows? Air is easy to ignore when everything is stable. You breathe it without thinking, move through it without resistance, and rarely consider how much it shapes the world around you. It carries sound, holds warmth, scatters light, and quietly connects everything on the surface of the planet. But after an event like this, the atmosphere is no longer invisible in the same way. It becomes active, noticeable, something that changes how everything looks and feels. In the time following the collision, the air above the planet would begin to fill with material that was never meant to be there in such quantities. Not just dust in the way you might imagine from a dry road or a windy day, but vast amounts of fine particles lifted from the surface and carried upward during the impact. Rock that was once part of the ground has been broken, heated and dispersed. Some of it was thrown outward at high speeds, some of it was lifted into the upper layers of the atmosphere, and now all of that material begins to spread. At first, the distribution would not be even. Closer to the impact region, the concentration would be much higher. The air there would appear thick, filled with suspended particles that reduce visibility and alter the way light passes through. But the atmosphere is not static. Air moves, currents flow, pressure differences drive circulation across the planet, and over time those currents begin to carry the material outward, from one region to another, across continents, across oceans, the particles spread. Now, as this happens, one of the first noticeable changes would be in the sky itself. Under normal conditions, the sky appears blue during the day because of the way sunlight interacts with the atmosphere. Shorter wavelengths of light scatter more easily, giving the sky its familiar colour. But when large amounts of dust and other particles are introduced, that interaction changes. Light is scattered differently. Some wavelengths are blocked more than others. The result is a sky that no longer looks quite the same. It might appear muted, less vibrant. The blue could become pale, or shift toward other tones depending on the composition of the material in the air. Sunrises and sunsets, which already produce changes in colour, would become more pronounced. The presence of additional particles can enhance scattering, leading to deeper reds and oranges, but at the same time the overall clarity of the sky would be reduced. Details that were once sharp might become hazy, distant objects less distinct. Now, as the particles continue to spread, they begin to influence not just the colour of the sky, but the amount of light that reaches the surface. Some of the incoming sunlight is blocked, not completely, but enough that the overall brightness during the day decreases slightly. Again, this is not an immediate dramatic change. It develops over time. As more material is distributed throughout the atmosphere, the effect becomes more noticeable. Days might feel dimmer, not dark, but less clear, less direct. And this change in light has further consequences, because sunlight is not just illumination, it is also a source of energy. It warms the surface, it drives weather systems, it supports processes that depend on its presence. When the amount of sunlight reaching the surface is altered, those processes begin to shift. Now, alongside the changes in light, there is another factor: heat. The collision introduced a large amount of energy into the system. Some of that energy was converted into heat within the atmosphere itself. Air was compressed and heated. Material entering the atmosphere during and after the impact generated additional heat through friction, and now that heat begins to interact with the rest of the system. At first, certain regions might experience elevated temperatures, not necessarily everywhere at once, but in areas where the energy was more concentrated. Over time, as the atmosphere redistributes heat, the effects spread. Air currents carry warmth from one place to another. Temperature differences drive movement. The system becomes more active. Now, the presence of dust and particles in the atmosphere also affects how heat is retained. Some particles can trap heat, preventing it from escaping as easily. Others reflect sunlight, reducing the amount of energy that reaches the surface. The balance between these effects determines how temperatures evolve, and that balance is not simple. It depends on the composition of the material, the size of the particles, their distribution. All of these factors interact, which means that the atmosphere becomes more complex, more variable, more difficult to predict. Now, from a personal perspective, these changes would manifest in ways that feel gradual. The sky looks different, the light feels different, the air might seem thicker, though not in a way that is immediately overwhelming. You might notice that distant objects appear less sharp, that the horizon seems slightly blurred, that the quality of light throughout the day has shifted. At first, these changes might be subtle enough to adapt to, but as they continue, they become part of the new normal. Now, alongside these visual and thermal changes, the movement of air itself would also evolve. The atmosphere, already disturbed by the initial impact, continues to respond. Air currents shift, pressure systems adjust, wind patterns may change, not in a single, uniform way across the entire planet, but in ways that reflect the new distribution of energy and material. Some regions might experience stronger winds, others might see changes in the timing or direction of air movement. Again, this is part of the system adjusting, responding to new conditions. Now, as time progresses, the particles in the atmosphere do not remain suspended indefinitely. Some of them begin to settle. Gravity pulls them downward. They return to the surface gradually over time, but not all at once, and not uniformly. The process of settling depends on particle size. Larger particles fall more quickly. Smaller ones remain suspended longer, which means that the atmosphere continues to carry material even as some of it is removed. This creates a dynamic balance. Material is added, material is redistributed, material is removed, and throughout this process, the appearance and behaviour of the atmosphere continue to change. Now, one of the most noticeable long-term effects would be the persistence of reduced visibility. The air remains filled with fine particles for an extended period. The sky retains a hazy quality. Sunlight continues to be filtered, and this influences daily experience. Not in a way that stops life entirely, but in a way that alters how the environment feels. Now, it's important to remember that all of these changes are connected. The atmosphere does not operate independently of the surface. It interacts with the oceans, with the land, with the energy that moves through the system. So as the atmosphere changes, it influences other parts of the planet, and as those parts respond, they in turn influence the atmosphere. This feedback creates a system that continues to evolve. Now, over time, the most intense effects would begin to diminish. Particles settle, energy redistributes, the system moves toward a new equilibrium. But that equilibrium is not the same as before. The composition of the atmosphere has changed. The distribution of energy has shifted. The conditions that define the environment are different. Now, from the perspective of someone experiencing this, the changes would feel like a gradual transition. The sky that once felt clear now feels altered. The light that once felt familiar now behaves differently. The air itself becomes something you notice more often, not because it is suddenly overwhelming, but because it is no longer entirely transparent in its effects, and this awareness becomes part of daily life. Now, as the atmosphere continues to adjust, the next stage begins to take shape. Because while the air is changing, the surface beneath it is also evolving. The distribution of land and water has shifted. The structure of the planet has been altered. And these changes begin to define what the Earth will become moving forward. Because after the immediate aftermath, after the reshaping of the surface and the adjustment of the atmosphere, the planet begins to settle into a new form, not stable yet, but moving in that direction. And that leads to the next question. What does the Earth actually look like now? How have the oceans and continents changed in response to everything that has happened? The shape of the Earth is no longer something you can take for granted. What once felt permanent, coastlines, continents, the boundaries between land and sea, has shifted enough that familiar maps no longer describe what exists. The outlines that defined the world for so long have been altered, not in small ways, but in ways that become clearer the longer you look. At first, the changes might seem fragmented, a coastline that no longer matches its previous curve, an area of land that appears lower than before, a region where water has moved farther inland and stayed there. But over time, those individual differences begin to form a larger pattern. The geography of the planet has changed, not completely unrecognizable in every location, but different enough that the relationships between land and water are no longer the same. And it all begins with the oceans. Water, as always, responds quickly. During the earlier stages, the tides grew stronger. The oceans became more active. Now, after the collision and the atmospheric changes, the distribution of water begins to settle into a new arrangement. Some areas that were once dry remain covered, not just temporarily during high tides, but more consistently. Low-lying coastal regions would have been among the first to change. Places where the land meets the sea at a gentle slope are especially sensitive to shifts in water level. Even a relatively small rise in average sea level can translate into a significant horizontal movement of the shoreline. So coastlines that once stretched outward may now be pulled inward. Beaches that extended for long distances may be reduced or altered. In some cases, areas that were once part of the land become part of the ocean, not suddenly, but through a process of repeated exposure and gradual change. Now, at the same time, there are regions where the opposite might occur. Because the Earth's surface has been reshaped by the collision, some areas have been pushed upward, others have shifted downward. The distribution of elevation across the planet is no longer what it was, and because of that, water does not simply rise uniformly everywhere. It responds to the new shape of the land. In some places, newly elevated regions might emerge. Areas that were once lower may now stand higher relative to sea level. In others, the land may have subsided, allowing water to move in and remain. This creates a patchwork of changes, not a single, uniform adjustment, but a complex rearrangement of where land ends and water begins. Now, over time, as the immediate disturbances settle, the oceans begin to find new equilibrium levels. Water seeks balance. It redistributes itself according to gravity and the shape of the planet. But that balance is now based on a different surface, a different set of elevations, which means the final arrangement of oceans and continents is different from before. Now rivers would also respond to these changes. Their paths, once shaped by long-standing geography, may no longer follow the same routes. If the land has shifted, even slightly, the direction of flow can change. Water moves downhill, so if the slope of the land is altered, the path of a river adjusts. Some rivers might carve new paths, others might slow, spread out, or even form new bodies of water where none existed before. Lakes could form in areas where water collects. In other places, existing lakes might drain differently or change shape. All of this contributes to the evolving landscape. Now, as the oceans and freshwater systems adjust, ecosystems would also begin to shift. Not immediately in a fully developed way, but gradually, as the environment changes. Marine environments would respond to the new distribution of water. Shorelines, which are often rich in life due to the interaction between land and sea, would move. Organisms that depend on specific conditions would need to adapt to the new locations of those conditions. On land, the changes in geography would influence where water is available, where it collects, where it flows. This in turn affects vegetation. Over time, patterns of plant life would begin to adjust to the new environment. Now, from a human perspective, the most noticeable aspect would be the loss of familiar reference points. Maps that once guided navigation would no longer be accurate. Cities that were once inland might find themselves closer to water. Others that were coastal might now experience different relationships with the sea. The sense of place, which depends on stable geography, would need to be redefined. People would begin to describe locations in new terms, new boundaries, new landmarks, because the old ones no longer apply in the same way. Now, it's important to remember that not all areas would be equally affected. Some regions might retain more of their original structure. Others might change significantly. The extent of change depends on how the energy from the collision was distributed, how the surface responded, and how water moved in response to those changes. But overall, the planet would present a new configuration, a new arrangement of land and sea. Now, as time progresses, these changes would begin to stabilize, not immediately but gradually. The most dramatic shifts occur early. Over time, the rate of change slows. The system moves toward a new balance. But even as that happens, the new geography remains. The Earth is not returning to its previous state. It is settling into a different one. Now, from a broader perspective, this transformation highlights something important. The shape of a planet is not fixed. It is the result of processes that usually operate slowly. But when those processes are accelerated by a large event, the changes can occur more quickly, and the result is a new configuration. Now, as the oceans and continents settle into this new arrangement, the focus begins to shift again. Because geography is only one part of the environment, the distribution of land and water influences many other systems. And as those systems respond, the question becomes more specific. What happens to life in this new environment? How do living systems respond to the changes in geography, atmosphere, and energy? Life does not disappear all at once. It doesn't switch off like a light. Instead, it responds. It adjusts, sometimes quickly, sometimes slowly, depending on what kind of life it is and where it exists. And in a situation like this, where the planet itself has changed in so many ways, the question is not simply whether life survives or not. It becomes more specific. What kind of life? Where? And under what conditions? Because not all forms of life experience change in the same way. Some are highly sensitive to their environment, Others are remarkably resilient, and that difference becomes important. Now, in the immediate aftermath of everything we've described, the conditions on the surface of the Earth are no longer what they once were. The atmosphere has changed, the distribution of light has shifted, the geography has been altered, temperature patterns have adjusted, and all of these factors influence living systems. For many organisms, especially those that rely on stable conditions, these changes would be difficult to adapt to quickly. Plants, for example, depend on sunlight. They use it as a source of energy. If the atmosphere is filled with particles that reduce the amount of light reaching the surface, that process becomes less efficient. Growth slows. In some cases, it might stop altogether for certain species that require specific conditions. Now, this doesn't happen uniformly everywhere. Some regions might still receive enough light, others might be more heavily affected. But overall, the availability of energy from sunlight becomes less predictable, and that influences the entire food chain. Because plants form the base of many ecosystems. If their growth is affected, the organisms that depend on them are also affected. Now, animals, especially larger ones, tend to rely on established patterns. They depend on predictable environments, consistent sources of food, stable temperatures. When those patterns change, adaptation becomes more challenging. Some species might move, seeking areas where conditions are closer to what they need. Others might struggle to adjust. Now, this is where smaller organisms become important, because life at the microscopic level operates differently. Bacteria, for example, are found in a wide range of environments. Some live in conditions that would be considered extreme from a human perspective. High temperatures, low temperatures, environments with limited resources. They're adaptable, not in a conscious way, but through processes that allow them to survive in a variety of conditions. And because of that, they're often among the most resilient forms of life. Now, in the oceans, life also responds. Marine ecosystems are influenced by changes in water movement, temperature and chemistry. As the oceans adjust to the new geography and the altered gravitational influences, the conditions within them change. Some areas might become more active, currents shift, nutrients are redistributed. This can affect where certain organisms thrive. Some species might benefit from increased mixing of nutrients. Others might find their usual habitats disrupted. Now, it's important to understand that life has faced changes before. Over long periods, the Earth has gone through different conditions, climate shifts, geological changes, events that altered the environment. And in those situations, life did not disappear entirely. It changed. Different forms became more common, others became less so. The composition of life on the planet evolved in response to new conditions, and something similar would happen here. Not immediately, not in a way that restores everything quickly, but over time, as the planet settles into its new state, life begins to adapt. Now, in the short term, the conditions would be challenging for many organisms. The changes in light, temperature and environment create situations that are outside the range of what many species are used to. But adaptation is a process. Some organisms can adjust their behavior, others rely on genetic variation over generations, and some simply exist in conditions where the changes are less severe. Now, from a human perspective, the question of survival becomes more personal, because humans depend on the environment in specific ways. Food systems, water sources, shelter. All of these are influenced by the conditions of the planet. Changes in geography affect where people can live. Changes in the atmosphere affect climate. Changes in ecosystems affect the availability of resources. Now, humans also have the ability to adapt in ways that many other species do not. Through technology, through planning, through movement. But even with those capabilities, the scale of change we are describing presents challenges, not insurmountable in all cases, but significant. Now, it's worth noting that survival does not necessarily mean maintaining the same way of life. It means continuing to exist under new conditions, and those conditions would require adjustments, different approaches, different strategies. Now, as time progresses, the environment begins to stabilize, not immediately, but gradually. The atmosphere settles, the distribution of energy becomes more consistent, the geography reaches a new balance, and within that environment, life begins to reorganize, not returning to exactly what it was, but forming new patterns, new relationships between organisms and their surroundings. Now, this process takes time. It does not happen in a single moment, but it is continuous, life responding to the conditions that exist. Now, looking at this from a broader perspective, it highlights something important about life on Earth. It is not fixed. It is not static. It changes. It adapts. It responds to the environment. And while some forms may struggle under new conditions, others may find ways to persist. Once the immediate survival question is addressed, another question naturally follows. Has anything like this ever happened before? Not exactly in the same way, but are there events in the history of the Earth that resemble this kind of transformation? Looking back at everything that has unfolded, it's natural to wonder whether any of this has ever happened before. Not in the exact same way, not with the same sequence of events or the same outcome, but something similar. Something that connects this imagined scenario to the deeper history of the Earth itself. Because while the idea of the moon crashing into Earth feels unusual, even unsettling, the early history of our planet was not quiet or stable in the way we experience it today. It was active, dynamic, filled with interactions that shaped the world long before anything like modern life existed. And among those events, there is one idea that stands out as particularly relevant: the giant impact hypothesis. This is a scientific explanation for how the moon may have formed in the first place, not as something that was always there, not as an object that simply appeared in orbit, but as the result of a collision, a very large collision. Now, according to this idea, early in the history of the solar system, when planets were still forming and the environment was far more chaotic than it is now, a Mars-sized object collided with the young Earth. This object is often referred to as Theia. The collision was not a direct head-on impact. It is believed to have been more of a glancing interaction. But even so, the amount of energy involved was enormous. Material from both the Earth and the impacting body was ejected into space. Not all of it escaped. Some of it remained in orbit around the Earth, and over time that material began to come together, to accrete, to form a new body, the Moon. So in a sense, the Moon itself may be the result of an earlier version of what we've been imagining. Not identical, not the same sequence, but related in principle. A large-scale interaction between planetary bodies, energy being transferred, material being reshaped, and something new emerging from that process. Now, this connection is important, because it reminds us that the Earth-Moon system has not always looked the way it does now. It has evolved, over time, through processes that involve both stability and disruption, and the current state, the one we are familiar with, is just one point along that timeline. Now, in the case of the giant impact hypothesis, the result was the formation of the Moon. Material that once belonged to Earth and another body became a new object in orbit. Over time, that object stabilized. Its orbit settled. Its relationship with Earth developed into the balance we described earlier. But that balance is not permanent in an absolute sense. It is the result of conditions that can, in principle, change. Now, it's worth considering how different that early Earth would have been compared to the one we know today. At that time, the surface was still forming. The crust was not as stable. The environment was more extreme. The processes that define the planet now, oceans, atmosphere, stable continents, were still developing, which means that the consequences of a large impact would have been different as well. Not necessarily less significant, but occurring in a system that was already in flux. Now, comparing that to the scenario we've been exploring, the key difference is that today's Earth is a more developed system. It has established structures, established patterns, life, ecosystems, complex interactions between atmosphere, oceans, and land. So while the idea of a large impact is not entirely new in the history of the planet, the context in which it occurs now is different, and that difference matters. Now, looking beyond the formation of the Moon, there are other examples in the solar system that show how common large impacts can be in shaping planetary bodies. Craters on the Moon itself are evidence of past collisions. Mars has features that suggest it experienced significant impacts. Even Earth, though much of its early history has been reshaped by geological processes, shows signs of past impacts. These events are part of the broader process of planetary evolution. They are not everyday occurrences, they are not common on human timescales, but over millions and billions of years they contribute to how planets develop. Now, in most cases, these impacts involve smaller objects, asteroids, comets, bodies that are much smaller than the Moon, but the principles are similar. Energy is transferred, material is displaced, the surface is altered, and over time, the system adjusts. Now, the idea of something as large as the Moon colliding with Earth again is extremely unlikely under normal conditions. The current orbital dynamics of the Earth-Moon system are stable. The Moon is gradually moving away, not inward. There are no known mechanisms that would naturally reverse that process in a way that leads to a collision, which means that the scenario we are exploring is hypothetical, a way of understanding how the system would respond if certain conditions were different. Now, this doesn't make it less meaningful, because exploring these possibilities helps us understand the underlying physics, the relationships between gravity, motion, and structure, how systems behave under extreme conditions, and how planets respond to large-scale changes. Now, returning to the idea of the past, it's interesting to consider that the Moon, which we see as a stable companion, may have originated from a much more dynamic and energetic event. Its existence is tied to a moment of transformation, a moment when the Earth itself was reshaped, and from that, a new system emerged. Now, in our scenario, we're essentially reversing that process in a different way. Instead of material coming together to form the Moon, we are imagining the Moon moving inward, interacting with Earth again. Not forming something new in orbit, but merging with the planet. And while the details differ, the underlying theme is similar: change, transformation. The idea that planetary systems are not fixed forever, but evolve over time. Now, from a broader perspective, this highlights something important about the universe. Stability exists, but it is often temporary. Systems can remain in balance for long periods, but that balance depends on conditions that can, in principle, change, and when they do, the system responds. Now, bringing this back to the present scenario, understanding that something similar may have happened in the distant past provides context. It shows that large-scale interactions are not outside the realm of possibility in the history of a planet. They are part of how planets form and evolve, but it also highlights how different the present is from that early stage. Because today, the Earth is not a forming planet, it is a developed system with established patterns, and any major change would interact with those patterns in ways that are different from the early solar system. What remains after everything settles is not the same world that existed before, not slightly different, not altered only in a few places, but a planet that has moved into a new state, shaped by everything that has happened, carrying the consequences of that event forward into its future. At first, that future does not arrive all at once, it unfolds gradually. Because after the immediate effects, after the shock waves, the atmospheric changes, and the reshaping of the surface, the Earth begins a process that it has always been capable of. It adjusts, slowly, steadily, moving toward a new balance. Now that balance is not a return to what was. There is no reset, no way for the planet to simply go back to its previous configuration. Instead, the Earth begins to reorganize itself under the new conditions that now define it. The surface, which has already been altered, continues to evolve. The crust, still responding to the energy introduced during the collision, shifts over time. Tectonic processes, which normally operate slowly, continue their work, but now on a landscape that is different from before. Mountains may form in new places. Existing ranges may change. The boundaries between plates, already influenced by the earlier stress, continue to adjust. Now, alongside these geological processes, the distribution of land and water continues to settle. The oceans, which moved in response to the impact and the changing shape of the planet, begin to find more stable configurations. Water collects in the lowest regions, basins form, shorelines stabilize, though not in the same locations they once occupied. New coastlines emerge, new relationships between land and sea develop, and over time, these new patterns become the baseline. Now, the atmosphere also continues its process of adjustment. The particles that were introduced during the collision gradually settle out. Some return to the surface, others remain suspended for longer periods, but eventually, the overall composition begins to stabilize. The sky, which once appeared altered, begins to regain some clarity, not immediately, but over time. Light begins to pass through the atmosphere in ways that become more familiar. Temperature patterns, influenced by the earlier changes, begin to even out. Energy flows through the system in a more consistent way, and as that happens, the climate begins to stabilize under the new conditions. Now, it's important to recognize that stabilize does not mean return to normal. It means finding a new pattern, a new equilibrium that reflects the current state of the planet. And that equilibrium may be different in important ways. Average temperatures could shift. Weather patterns might follow new paths. Regions that were once warm might become cooler. Others might become warmer. The distribution of climate zones could change. And over time, these new patterns define how the environment behaves. Now, as the physical systems of the planet settle, life continues its process of adaptation. Organisms respond to the new conditions. Some areas might support life more easily than others. Regions where water, temperature, and light align in favorable ways become centers of activity. Other areas might remain less hospitable, and over time, ecosystems begin to form again, not identical to what existed before, but shaped by the current environment. Plants begin to grow in areas where conditions allow. Animals, depending on what has survived and what can adapt, begin to occupy these spaces. Microorganisms, as always, play a central role in this process. They respond quickly, they adapt, they form the foundation upon which more complex systems can develop. Now, from a human perspective, the concept of a new Earth would involve adjusting to these conditions, understanding the new geography, adapting to the new climate, finding ways to exist within the environment that now exists. This is not about restoring the past, it is about working within the present. Now, over longer periods, the changes continue. The Earth does not stop evolving. It continues to shift, to respond, to adjust, and in doing so, it moves further away from its previous state and more fully into its new one. Now, it's interesting to consider that over very long timescales, the memory of the original event becomes less immediate. The most dramatic changes occur early. Over time, processes smooth out the landscape. Erosion reshapes features. Sediment builds up in new areas. The surface becomes more stable, and as that happens, the planet begins to look more consistent again. Not the same as before, but not as visibly disrupted as in the immediate aftermath. Now, from a broader perspective, this process reflects something fundamental about planets. They are not static. They change, they evolve, they respond to events, and while some changes are gradual, others occur more quickly. But in all cases, the planet continues forward. Now, as the Earth settles into this new state, the relationship between the planet and the rest of the solar system remains. The Sun continues to provide energy. The gravitational interactions with other bodies continue. But one thing is different. The Moon, as it once existed, is no longer there. Its material has become part of the Earth, or has been redistributed, and that changes the system. because the Earth-Moon relationship was an important part of how the planet functioned. Now, without that same structure, or with a different configuration, the dynamics change. The tides, which were once driven by the Moon, would behave differently. The stabilizing effect on Earth's axis might be altered, and over time this could influence how the planet evolves further. Now, these are longer-term considerations, but they are part of the overall picture. The Earth is not just a surface, it is a system, and when one major component changes, the system responds. Now, as we consider this new Earth, it becomes clear that what remains is not defined solely by the event that created it. It is defined by what happens afterward, by how the planet adjusts, by how its systems interact, and by how those interactions shape the environment over time. Now, as this process continues, one final perspective begins to emerge, because after exploring what happens, after looking at how the Earth changes and what it becomes, there is still a broader question to consider, one that steps back from the details and looks at the overall picture. What does this scenario tell us about our place in the universe, about the nature of planetary systems, about the balance that allows our world to exist as it does? It's easy, after walking through a scenario like this, to feel as though it sits just beyond the horizon of possibility, close enough to imagine, detailed enough to feel real. But this is the moment where perspective becomes important, not to dismiss what we've explored, not to undo it, but to place it back into the broader context of how the Earth-Moon system actually behaves. Because in reality, the situation we've been following would require something very unusual to begin in the first place. Under normal conditions, the Moon is not moving toward Earth. It is moving away, very slowly, almost imperceptibly on a human timescale, but consistently. Every year, the distance between Earth and the Moon increases by a few centimeters. Not enough to notice in daily life, not enough to change how the Moon looks in the sky from one year to the next, but measurable, and more importantly, directional, outward, not inward. This outward drift happens because of the same tidal interactions we discussed earlier. The Moon pulls on Earth's oceans. The movement of those oceans transfers energy, and some of that energy is passed back into the Moon's orbit. As a result, the Moon gains a small amount of orbital energy, which causes it to move slightly farther away over time. Now, this process is stable. It has been happening for a very long time, hundreds of millions of years, and there is no natural mechanism currently acting on the system that would reverse it in a way that causes the Moon to begin spiraling inward. For that to happen, something would need to disrupt the balance, something large, something significant. Now, when we talk about large in this context, we're not referring to anything on the scale of human activity, not rockets, not satellites, not even the largest objects we've ever sent into space. The forces involved in the Earth-Moon system are immense. Changing that system requires something on a planetary or near-planetary scale. For example, a massive impact on the Moon could in theory alter its orbit. But the object required to do that would itself need to be extremely large, and events like that are extraordinarily rare. They do not happen on timescales that affect human civilization. Another possibility would be the gravitational influence of a large passing object, something with enough mass to disturb the Moon's orbit. But again, the conditions required for that are highly specific. A large object would need to pass close enough to exert a strong gravitational influence, but not so close as to create even more dramatic consequences for the Earth itself. And even then, the exact outcome would depend on the details of that interaction. Now, when we look at the solar system as it exists today, it is relatively stable. The planets follow predictable orbits. The major bodies interact in ways that have been well studied. There are no known objects on trajectories that would lead to a disturbance of this magnitude. So from a practical standpoint, the scenario we've been exploring is not something that is expected to occur. Not in the near future, not in the distant future. It is a hypothetical, a way of understanding what could happen under certain conditions, not what will happen. Now, this distinction is important, because imagining a scenario allows us to explore the physics behind it, to understand how gravity works, how orbits behave, how planets respond to large changes, but it does not imply that the scenario is likely. Now, taking a step back, it's also helpful to consider timescales. The universe operates on scales of time that are very different from human experience. Millions of years, billions of years, processes that unfold slowly over immense periods. Even when we talk about rare events, like large impacts, they are spaced out over these long timescales. So when we say something is possible, it often means possible over millions or billions of years, not within a time frame that affects our daily lives. Now, bringing this back to the Earth-Moon system, the current trajectory is one of gradual separation. The Moon is moving away. The system is stable, and that stability is what allows life on Earth to exist as it does. The Moon's influence on tides, on Earth's axial stability, on long-term climate patterns, all of these contribute to the conditions we experience. Now, that doesn't mean the system will remain unchanged forever. Over extremely long timescales, changes do occur. The Moon will continue to move away. Earth's rotation will continue to slow. The length of a day will increase. These are gradual processes. They do not lead to a sudden collision. They lead to a different configuration of the system over time. Now, from a broader perspective, this highlights something important about our place in the universe. We exist within a system that is, for now, stable, balanced, predictable in the ways that matter for life. And while it is possible to imagine scenarios where that balance is disrupted, those scenarios require conditions that are not present. Now, this doesn't make the exploration any less meaningful. In fact, it does the opposite, because by understanding what would happen in an extreme scenario, we gain a deeper appreciation for the balance that currently exists. The fact that the Moon remains at a safe distance, that its influence is strong enough to shape the planet, but not so strong as to destabilize it, that the system operates within a range that supports life. Now, as we come to this point, the perspective shifts again, from imagining what could happen to recognizing what is happening. The quiet, steady motion of the Moon in its orbit, the predictable rise and fall of tides, the familiar presence of the Moon in the night sky. All of these are part of a system that works. For a moment, it helps to slow everything down again, not because anything needs to be undone, but because after following such a long chain of events, from the first subtle shift to the final transformation, the mind keeps moving forward, anticipating what comes next, even when there is nothing left to unfold. So instead, we return. Not to the beginning exactly, but to something familiar, the night sky. If you were to step outside now, or imagine doing so, the air would feel still in the way it usually does. The kind of stillness that doesn't demand attention, but quietly surrounds you. Above, the sky stretches out in the same calm way it always has, wide, open and unhurried. And somewhere up there, the Moon, not enormous, not rushing, not changing in ways that are easy to notice from one moment to the next, just present, exactly where you expect it to be. After everything we've explored, it's almost strange how normal that feels, because we've spent time imagining a version of events where that quiet presence changes, where it grows, moves, transforms, and eventually becomes something entirely different. We followed it step by step, watching how small shifts turn into larger ones, how a stable system can become something more active when the balance is altered. But here, in this moment, none of that is happening. The Moon is still at its usual distance, still following the same path it has followed for as long as human beings have looked up at it, and that difference between what we imagined and what is real is worth noticing. Not as a contrast meant to reassure or dismiss the scenario, but as a way of understanding how much stability is built into the system we live in. Because the Earth and the Moon are not simply sitting in place. They are moving, interacting. maintaining a balance that allows everything we experience to continue in a predictable way. The tides rise and fall. The phases of the moon change gradually over the course of a month. The sky shifts from day to night and back again. All of these patterns continue, and they do so quietly, without drawing attention to the complexity behind them. Now, after imagining what happens when that balance changes, it becomes easier to appreciate what it means for that balance to hold. The moon is close enough to influence the Earth, to shape the oceans, to stabilize the planet's orientation, but far enough away that those influences remain gentle, controlled, consistent. And that consistency is what allows everything else to function as it does. Now, as you look at the moon, or imagine looking at it, you might notice the same details as before, the familiar patterns on its surface, the way its light spreads softly across the sky, the way it changes shape over time. But perhaps there is a slight shift in how you think about it. Not dramatic, just a small awareness that what seems still is actually moving, that what seems simple is part of a much larger system, and that the stability we experience is not something guaranteed forever, but something that exists because of the conditions that are currently in place. Now, none of that needs to feel overwhelming. In fact, it can feel quite the opposite, because the system is stable. The moon is not drifting toward Earth. It is moving away slowly, over time. The balance we rely on is not fragile in the sense of being on the verge of change. It is robust, maintained by the laws that govern motion and gravity. And that means that, for all practical purposes, the moon will continue to be what it has always been in our lives: a steady presence, a quiet companion. Now, as the night continues, the moon will follow its path across the sky, rising higher or moving toward the horizon, depending on when you're looking. The stars will remain in place, distant and unchanged on human timescales. The air will stay still or move gently with the wind. Everything continues, and that continuation is part of what makes the experience of looking at the night sky so consistent, so familiar. Now, after spending time imagining what could happen, there is something grounding about returning to what is. The moon is there, calm, unhurried, exactly where it should be, and you can simply observe it, without needing to think about orbits or gravity or long-term changes, just noticing its presence, the way it lights the sky, the way it sits among the stars. Now, if you let your attention rest there for a moment, the experience becomes quieter. Less about understanding, more about observing. The details we explored remain in the background. They don't disappear. But they don't need to be active. They become part of the context, something you know but don't need to focus on. And in that quiet, the night returns to what it usually is: still, steady, uncomplicated. Now, as this moment continues, there is no need to move forward to anything else, no next stage to consider, no further changes to imagine, just the present, the sky, the moon, and the sense that everything is continuing as it has for a very long time, and will continue just as quietly for a very long time to come.